All right, good morning, grade 8s and 9s. I'm so sorry for joining a bit late than I had planned, but yeah, things happened. Things seriously happened. So today we are going to be looking at grade 9 maths paper 1. Just grade 9 maths paper 1. There's been some desire from some people that we do that, so I'm going to look at some grade 9 maths paper 1 concept theory aspects if you want. All right, and hopefully it will be a good session. Okay, it will be a good session. Hopefully it will be a good session for everyone. Okay, so if you have just come in and you're in grade 9, please do indicate in the comment section and let us please get the likes up to 10,000. Okay, I think that's a bit ambitious, but let's get the likes up to 1k, guys. 1,000 likes, so that we can attract more people coming in, so that we can actually look at this together. There are people that are struggling with this aspect of grade 9 maths paper 1, so let's get them here by attracting them through the likes. Let's double tap viciously on the screen. Let us double tap to the extent that we are nearly going to break our phones, so that we can get more people coming in to come and actually watch this grade 9 maths paper 1 aspect of the paper. So right, this is just generally a maths paper 1. All right, so let us log in. Let us log in. Okay, so there we have it there on the screen. Grade 9 term 4 examination. So we are taking a past paper, November 2023 specifically here for this one, and the question paper consists of 6 questions. Answer all questions on the question paper. We don't have the question paper that we can answer on, but calculators may be used unless stated otherwise, of course. And then it says if necessary round off to 2 decimal places unless stated otherwise. It is in your own it is in your own interest to write legibly and to present neat work. Yeah, whenever you're writing an exam, guys, we need to make sure that the work is neat. But for now, can we double tap, guys, on the screen? Let's double tap. Can we see? Can we double tap, please, guys? Double tap on the screen. Let's get this the likes of this live up to if we can get it up to 500, actually 1,000, that would be great. All right, yeah. Once we get it up to 1,000, then I'll start this live. I will start it. Okay. Yeah, grade 9 maths paper 1. This is what we want to look at. All right. So for those who will be writing a straight paper 1, this is for you, grade 9 maths paper 1. For those who will be writing GEC maths paper 1, this is also going to be applicable to you, because the content, even though maybe we are not doing a GEC paper, this will still be able to assist you as an individual. Okay, right? So yeah, can we just double tap for now and get the likes up to 1,000, so that I can start the session at 1,000 likes. Okay, let's share it out. Yeah, let's share out the live to as many people as we possibly can who are in grade 9, who are doing maths. Yeah, so we are there now. We've arrived at 1,000 likes, so let us start the session. Okay. Okay, the first question there says, choose the correct answer from the 4 options. Write only the letter in the space provided. 1.1, when 15 is divided by 0, it is A, rational, B, undefined, C, real, D, irrational. So which one is it, guys? When 15 is divided by 0, which one is it? Is it A, rational, B, undefined, C, real, D, irrational? Queen M says rational. So Queen M would answer this question and say A. All right, what does everybody else have to say? Queen M, I see your answer. What else does everybody have to say? When 15 is divided by 0, in brackets you can see there 15 divided by 0, it is A, rational, B, undefined, C, real, D, irrational. Okay, we have more answers in the comment section. Real 27 says undefined. Skylar Abraham says undefined. We have Bright Lungwani saying B. All right, so we have majority of the people here in the comment section saying it is irrational. Queen M, fantastic movie, says it's irrational because it can't have a square number. Interesting comment there. Fantastic movies. Apuema Peter says undefined. Right. Let's clear the air, guys. 15 divided by 0, guys. Any number divided by 0, we say that number is undefined. Undefined. So let's never mistake that, guys. So it definitely has to be B, undefined. The person who said rational, it can't be rational. Remember, guys, a rational number is a number that can be written as a fraction. So maybe someone else will say, but sir, 15 divided by 0 can be written as a fraction. Okay, you are correct. It can be written as a fraction. Remember, the rational number is a number that can be written as a fraction where A, which is the numerator, needs to be an integer, and B has to also be an integer. Now, 15 is an integer value, 0 is an integer value, but it says that the denominator B cannot be 0. So because the denominator here is 0, then we can't say this is a rational number. We would say it's rational if the A and the B were integers and the denominator was not 0. But unfortunately here, the denominator is 0, and 15 divided by 0 is the same thing as 15 over 0. Any number divided by 0, we say it is undefined. And guys, this is different from saying 0 divided by 15. Now, this is very different from that, because 0 divided by 15, yes, the numerator is an integer, the denominator is an integer, and you can see, guys, that the denominator is not 0. So therefore here, this one is a rational number. We can say that because 0 divided by 15 gives us a what? A 0. Unlike 15 divided by 0, which basically gives us a what? It gives us in the calculator maths error. But we say that any number divided by 0, that maths error means that the number is what? Is undefined. So I hope that explanation is clear. So we say that when 15 is divided by 0, it is B, guys. It is not A, because a rational number cannot have 0 in the denominator. It cannot be real because C, real number, guys, a real number is any number in the number line, and 15 divided by 0 is not any number in the number line. D, it cannot be irrational because an irrational number can be expressed as a non-recurring and non-terminating decimal. So 1.1, guys, when 15 is divided by 0, it is B, undefined. Okay, let's be very clear about that and not have confusions about that. So 1.1, guys, is B, undefined. undefined. So that is for everyone that may have thought otherwise. It is B, undefined. Okay. All right, I hope you understand. So I've just started, guys, because I woke up late. So I just started. For those who are joining, chill, relax. We just started grade 9 maths paper 1. So 1.1, when 15 is divided by 0, repeat again, it is undefined. Okay, let's move on to number 2. Hopefully, guys, as I move on to the next question, we have the next amount of likes, because remember we started this live when we wrote 1, we got to 1k likes. Now we are on 1.9. I'm moving on to the next question. Hopefully, as we move on to the next question, that 1,000 likes that we need, we have reached. So we are now there. We're at 2.0. Now we can continue. 1.2, simplify. We have there the square root of 9 over 16 x to the power 16, and they're saying, is the answer going to be A, 3 over 4 x to the power 8, B, 3 over 4 x to the power 4, C, 9 over 16 x to the power 8, or D, 9 over 16 x to the power 4? So which one is it? Real 27 says B. Okay, very quick, Real 27. Very quick, Mr. Real 27, in answering the questions. Crown B says B. Atandwa Bengu says A. Right? Atandwa Bengu, Emihle says B. Esihle says M. MT says A. Okay. So we have options A and B seemingly being the two that people are saying are the answer. So let's check. Tawanda Badoni says D. Now that is very interesting. Tawanda is saying something different from everybody else. Okay, so let's go and check what it is that we would do here. Guys, take note. The 9 over 16 is under the square root. Also, x to the power 16 is also under the what? The square root. So that means we can do the following. When under the square root we have something like this, a fraction, okay, either, then what we do is we can split the square root to the numerator and to the denominator. I hope that makes sense. And then we can apply the square root to the numerator and the denominator. So that means with divide, we can split. With multiply, we can also do what? We can split. Okay. So these are rules. For divide and multiply, if we have an expression under the square root and there's a division, A over B, meaning A divided by B, we can split the square root for both the numerator and the denominator. If we have multiplication, we can also split the square root for A and B. But, so the splitting only applies for multiplication and division. What about addition and subtraction? Okay, if we have addition and subtraction underneath the square root, can we split? No, guys. Okay, we cannot split. This is absolute nonsense. We cannot split the square root for when we have terms that are separated by a plus and minus sign. So we can't split here. Cannot. Right? So what we need to check is what is the relationship of everything that is inside the what? The square root. I hope that makes sense, guys. I hope you understand what. Right. We need to check what is the relationship between what is inside. So if we check here, 9 over 16. 9 is divided by 16, and then x to the power 16 is combined to 9 over to x to the power 16 by what we call multiplication. That's what combines this. So the relationship contained here is one of division and multiplication. What does that mean? It means you can split the square root, and in actual fact you can do that for everything, because the relationship is one of what? Division, and then this fraction is multiplied to x to the power 16, which combines it to that. Then what is the square root of 9? You can ask yourself. The square root of 9 is 3. What is the square root of 16? It is 4. And then how do you simplify the square root of a variable raised to the exponent 16? You write x to the power 16, and remember, since it's the square root, you can divide by 2. If it was the fourth root, you would divide by 4. If it was the cube root, you would divide by 3. That is how we actually simplify the variable raised to a particular exponent. So like I said, guys, since it's the square root, we divide by 2. We divide this exponent by 2. If it was the cube root, then we would divide by 3. If it was the fourth root, we would divide the 16 by 4. But now it is the square root. So our final answer, what is 16 divided by 2, guys? What is 16 divided by 2? Do we know? Thank you, Atandwa Bingo. It's 8. So therefore our final answer is 3 over 4 x to the power 8. That is the answer. So if we go back to our options in the multiple choice, 1.2, simplify 9 over 16 x to the power 16. Is it A, 3 over 4 x to the power 8, B, 3 over 4 x to the power 4, C, 9 over 16 x to the power 8, or D, 9 over 16 x to the power 4? Now you can see clearly now the rain is gone. It is definitely B. No, obviously not. It is A. All right, it is A. That is A. Okay, no, you can't say well done to those who said B. It is not B, it is A. All right, it is A. 3 over 4 x to the power 8. So let's make sure, guys, once we get the right answer, we look at the options, we make sure that we select the correct answer. There it is. So it has to be A. Let's move on to number 3. 1.3. The product of 2x into x minus 4 is A, 2x minus 4, B, 2x squared minus 8x, C, 2x squared minus 4x, D, 2x minus 4x. Atandwa Pengu immediately says B, Crown Up says B, Real 27 says B, and Esihle MT says B. Seems like these are the only people that are actively present in the live session at this present moment. And I want to applaud all of you that are actually participating actively by using the comment section to respond with your answer. All right. Okay. Now we have a few people that said B and the, all right. Yeah. All right. Emihle, where did you get the 2 from? I don't understand what you mean. Where did I get the 2 from? You mean the exponent. Remember, Emihle, I explained this thing, all right? I said this is the square root. Something that people don't understand is that the minute you have the square root, there is an invisible 2 that is there that people usually don't acknowledge. But nonetheless, whether you write the square root as this or you actually show the 2 being there, what you need to understand is that the minute you decide to remove the square root, you decide to remove the square root for the purpose of simplifying. Let's say you had x to the power 4. here. Then what you would then do is you would say x to the power 4 divided by 2. Why divided by 2? Because this is the square root. I am saying also, if it was x to the power 9, for instance, and we had a cube root, how do we remove this? How do we basically simplify this? We would say x to the power 9 divided by 3. So we are always dividing by the root that there is. That's why the rule generally says this: the x to the power m raised to the nth root would be equal to x to the power m over n. That's how you write roots into exponential form. That's how you write roots into exponential form. So hopefully the one who was asking the question, you understand me now. Okay, this goes back to what you were supposed to understand when you were doing exponents, my beloved grade 9s. Okay, are we good now? Hopefully you understand. So like I said, the square root of x to the power 4, this means there's a 2 there. The minute you want to simplify this, you can write it in exponential form using this rule, because it says x to the power m to the nth root is actually x to the power m over n. That's how you express this as a rational exponent. So in the same way, where did I get the 2 from? Remember, it was the square root of x to the power 16. So that means there's a 2 there. So what do I do? To remove the square root, I say x to the power 16 divided by 2, which gives me x to the power 8. So that's where I got the 2 from. Okay, so hopefully that's clear for you. 1.3, guys. So the product of 2x to the power into x minus 4 is equal to, so let's check, 2x into x minus 4. The product, remember, in maths, brackets mean multiply. Brackets mean multiply. So we have a 2x, which is a monomial, one term, and then x minus 4, because it's in bracket, is also a monomial, but it consists of what? Of 2 terms inside the bracket, because terms are separated by a plus and a minus sign. So what we do is we take this one term, and what do we do to it? We distribute it. Why? Because brackets mean multiply. So we are going to multiply 2x and x minus 4 using the distributive law. And when we do so, we apply what I call sign, number, letter. We consider the sign, the number, the letter. You see these in the movies, guys. These are bad when you are seeing a movie. SNL, you don't ever watch a movie with SNL. But in maths, S means sign, N means number, and L means letter. So when you multiply the sign, you multiply the number, you multiply the letter, you multiply the sign, you multiply the number, you multiply the letter. So the next time you are watching a movie and you see SNL, it's good time to actually switch off that TV, switch off that phone, switch off that whatever, and go and practice some maths where you can actually get affluent and good in your mathematics. So S means sign, N means number, L means letter. DL means the distributive law. So you apply the distributive law, guys. Okay, you apply the distributive law, applying multiplication of sign, multiplication of number, multiplication of letter. Look at this. 2x multiplied with x means I'm going to look at, this is distributing 2x to x, and you are going to multiply when you distribute, applying what? Sign. Positive times a positive, because 2 is positive and 1x is positive. Positive times a positive is positive. Then number, 2 times, there's a 1 here that you cannot see. What's 2 times 1? It is 2. So the number is multiplied as well. I've done the sign, I've done the number. Now I'm going to the letter. X times x. The laws of exponent says when we multiply same bases, what do? We keep the base. Well, then what do we do to the exponents? We add the exponents. There's an exponent 1 that you cannot see here, and there's an exponent 1 that you cannot see there. They are like the Holy Ghost. Today is Sunday, guys. You know, you cannot see some things in maths, but they are there. They are present. 1 plus 1 gives us 2. So the first term that we have, applying the distributive law using S and L is 2x squared. But we don't end there. We distribute 2x to negative 4 as well. Because inside this bracket, there are how many terms? There are 2 terms. So we take this one term, we distribute it using the distributive law, using multiplication, doing S, multiplying the sign, multiplying the number, multiplying the letter. So what is 2x times negative 4? So we start with the sign. Positive times a negative is negative. We move on to the number. 2 times 4, because we are done with the letter, with the sign. 2 times 4 is 8. Then we move on to the letter. X times, there's no other letter there, so that means the X gets stuck next to the 8. We are done. These are the terms that are a result after distributing the what? The 2x into x minus 4. The brackets are gone. So our final answer, the product of 2x into x minus 4 is actually equal to 2x squared minus 8x. We cannot add these terms. Why? Because these are unlike terms. Why do we say they are unlike terms? Even though this one has x and this one has x, the exponents are different. So we cannot subtract 2x squared and 8x. We leave the expression like this. The answer is 2x squared minus 8x. So now we can go to our options. We wanted to know which answer satisfies. What is the product of 2x into x minus 4? So those that said the answer is B were 100% correct, and they were 100% on point. So that means the answer is what? It is B. Okay, right. Good on you, crown up. Good on you. So the answer is B. Okay. Any questions? Does 8x not have an invisible one? The only invisible one that 8x has is the one that is an exponent. Okay. That one that is an exponent is invisible. It is there, but you cannot see it. That's what's invisible, all right? But the 8 is a coefficient next to the x. So the only one that is there is the invisible one that is an exponent. This exponent x has a 2 that is an exponent. It is visible. This x has an exponent that is 1. The exponents are different, so you cannot subtract these two. You leave these terms as they are, because the rule says you cannot add or subtract unlike terms. Okay, let's move on to number 4 now. Number 4 says if a is equal to negative 2, then the value of negative 2a to the power 3 is a 16, b 8, b negative 16, c 8, d negative 8. Now Atandwa says 16, all right, and the Prince says A. He agrees with Atandwa. Guys, let's remember that when we write our answer, we write the letter there, okay? We don't write the actual number, okay? Real 27 says A. Swag Tando says C, but there's a question mark. Ntsakelo says A. Crown Up says A. Yesihle MT says negative 8. Yesihle MT says D now, all right, with the letter, because I'm sure she picked up on what I just said. So let's look at what we do in questions like this. If A is equal to negative 2, then the value of negative 2a to the power 3 is. So let's go check it out. Let's go and see what do we do in question like this. If a is equal to negative 2, so that means a is negative 2. In the place of a here for this expression, we can substitute, we can sub a is equal to negative 2. So let's come here, rewrite the expression, then in the place of a, in brackets, guys, we substitute negative 2 raised to the power 3. Okay, negative 2 raised to the power 3. Then remember, we apply what I call BODMAS. Let's never forget. Okay, maybe in lower grades you knew it as BODMAS. B means brackets. We always start with the brackets. E means exponent. After the bracket, we always take out the exponent. D means division. M means multiplication. A means addition. And S means subtraction. So when we have an expression and we want to simplify it, we look at it and we check where are the brackets. So for now, I'm going to write this -2 outside. It's going to wait, and I'm going to look at the brackets. In the brackets, I can see that outside there's an exponent, so which means I'm going to first look at the brackets and apply the exponents. That's the order in which I operate. I start there. So what's -2 raised to the power 3? Now, guys, there's a couple of rules here. When you have an odd number that is applied for something that is in the brackets, we must first apply that odd number first to the what? To the sign. Then apply to the what? The number. Then we apply to the what? The letter. Once again, SNL is featuring. We avoid these movies, guys. Remember, what does the S stand for? It stands for the sign. N stands for number. L stands for letter. So we apply the exponent to the sign first. An odd number exponent. This is an odd number, guys. Odd, odd, odd. So if you apply an odd number to a negative sign, the odd number applied to the negative sign makes the negative sign stay. But if this was an even number applied to a negative sign, the negative sign would change to positive. Okay, so please, guys, take note of this. Okay, if the exponent is an odd number, when we apply that odd number exponent to a sign that is negative, it stays negative. Okay, but if you have an even number exponent applied to a sign inside the bracket that is negative, then that negative sign will change to a positive. All right, this is something very important to note. Odd number applied to a negative sign leads to a negative sign. An even number applied to a negative sign, if it's an even number exponent, then the answer for the sign will be positive. So when we apply the odd number exponent to the negative sign, it becomes what? Negative, as the rule indicates. Then what's 2 to the power? Remember, 2 to the power 3, that gives us 8. Okay, now we are done with the bracket and the what? And the exponent. We move on. D, division, no division. M, multiplication. Now remember, brackets mean multiply. This -2 can now be multiplied with -8. So what's A? Once again, S, negative times a negative. That gives us a positive. What's 2 times 8? Number. That gives us positive 16. There's no letter, so that means our answer is 16. Okay, answer is 16. So let's move and go and check our answer that we were supposed to choose. Is it A, 16, B, -16, D, 8, C, 8, or D, -8? So those that said the answer is 16, A, you guys were 100% on point. So Tawanda, very good. Good on you. Crown up. I can see you are clapping all the way. You've been clapping. You've been getting the answers. So that's the answer, my beloved grade 9s. Okay, yeah, and Esihle as well. Good job, guys. Let's move on to 1.5. Thank you for 10k likes. Thank you so much, guys. We are on 10k likes. Very good. Thank you so much. I really appreciate the likes. Let's go now and answer 1.5. The gradient m of the line y is equal to half x minus 6 is A, 6, C, 1, B, -6, D, half. I repeat, A, 6, B, -6, C, half, C, 1, D, half. Right? So I can see Steezy is saying the answer is B, Prince is saying it's D. B dot is saying A, and there's a question mark, right? But we have Tawanda saying D, Substance saying D, Rufiwa saying D, Esihle saying D, Long Lasting and Tsakelo saying D, and Esihle MT, Real 27, as usual, answering like flash lightning speed, saying D. So let's check this. Mr. K asking, where can I get the paper? Yeah, this was basically a paper that I got from last year somewhere. I don't particularly know where you can get it now, but it's just that I saved it up, on my phone. So let's look now at 1.5. Y is equal to half x minus 6, and let's try and remind ourselves some important things that we may have forgotten. Remember, this is under the topic straight line graphs. Thank you, Crown Up, for answering my beloved friend there, Mr. K. I think you can check that, Mr. K. Check it on past paper essay. Thank you so much, Crown Up. I say Crown Up is a real-time practice. I practice like nobody's business, Crown Up. Y is equal to half x minus 6. Remember, this is a linear function. Okay, this is a linear function. It's in the form y is equal to mx plus c. All right. And remember, m stands for what, guys? For the gradient. But it stands for gradient only when the linear function is in the standard form. The standard form of a linear function is y is equal to mx plus c. That is the standard form. Okay, that is the standard form. Okay, I hope that makes sense, guys. Y is equal to mx plus c. This is the standard form of a linear function. So if you look at this linear function, it is in standard form, which means m, the gradient, we should be able to read what it is. Then let's remind ourselves as well, what about c? What is c? Do we still remember, guys, what c is from the linear function? Okay, do we remember what c is? The last term of the actual function. What do we call this? What is c referred to? If m is the gradient, what do we call c? We say c is the y-intercept. Thank you, Londil. Y-intercept. What is that? It's where the straight line cuts or overlaps or crosses the y-axis. Okay, this y-intercept, that is basically the value where the graph or the straight line cuts, crosses, or overlaps the y-axis. So I repeat again, m is the gradient, but we only say it is the gradient when the equation is in standard form. Our responsibility whenever we are given a straight line equation is to ensure that it is in standard form. The standard form of a linear function is y is equal to mx plus c. The m in this form means gradient. So the question was saying, what is the gradient of this particular function? So guys, I'm sure you can see. We simply check the coefficient of x, therefore we say the gradient is half. Okay, the gradient is half. That's what the gradient is for this function. So 1.5, which option should we have chosen? For sure. 1.5, the option that really makes sense, is D, not A, not B, not C. Now sometimes people think that it can be C because people take this one to be the coefficient of the x term, and it isn't, guys. The coefficient means whatever is next to the x, the numerator and the denominator, including the sign. So for instance, if this was negative half x, I would actually write down the gradient as a negative half. So the coefficient of x, in other words, that thing that stands next to the x is what we call the what? The gradient. No problem, Sectando. You must go to church. All right. Remember, I upload these videos in the YouTube channel when I'm done, so you can watch when you come back from church and remind yourself. I'll save it as grade 9 maths paper 1, November preparation 2025, and you can watch that video when you come back from church. Wherever you stopped, you can fast forward and watch it in the YouTube channel. Remember, the link is in my bio. Okay, the link is in my bio. Yes, Real 27, very good. I love what Real 27 is typing there in the comment section. They could trick you and say x over 2 minus 6. Okay. Does that make sense, guys? They could trick you. But remember still, when you always say, okay, what is the coefficient? The coefficient of x here is 1. But what is in the denominator? It is 2. So therefore, together, everyone. Okay, the coefficient is 1 over 2 still. So don't let them trick you by saying x over 2 and then you're like, you panic, you're like, it must be 1. No. It is 1 over 2. The entire thing that is next to x becomes the gradient of the function. Okay? So let's not be confused. So D is the answer that we all should love and know. Okay, now moving on, guys, to the next question. Right. Question number 2. Under numbers, write the numbers in descending order. Hopefully, guys, we know what descending means. All right, we are done with the multiple choice. So if you got 5 out of 5 for the multiple choice, good job. All right, because at the end of the day, we need to get total, guys. 100% is something that is possible. Write the numbers in descending order. The word descending means from big to small. Okay, when you think of descending, think of down. Descending, go down. So you want to start from the biggest number, highest, to the lowest number. So we have negative 203, we have negative 2301, we've got 166, we've got 5, we've got negative 2, and we've got 97. What we want to do there is we want to write from the biggest number to the smallest number. So let's be very, very careful, guys, that the biggest number obviously cannot be negative. The biggest number has to be a positive number. All right, so for instance, look at my guy here, 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 look at the pinned comment. Hey, look at that answer, negative 2301. Are you kidding me? Followed by negative 203, followed by negative 2, then 5, then 97. This person that I have a comment pinned would be correct if the question was saying write the numbers in ascending order, because if it was ascending order, that means up. We're not going down anymore, we are going up, meaning we start from smallest to biggest if the question was saying ascending order. So let's be aware of the question. This one is saying descending order, not ascending order. So if it is descending order, it means we are going down. Let's look at this kind say here, right? So let's be very careful, very, very careful when we write our answers. Let's look at this one. Mr. K there also has answered. All right, and I can see Tawanda is very much happy celebrating that answer. So hopefully we all understand that the answer to the question would be definitely as Mr. K has indicated in the comment section. So our answer there, if we're writing it down, would be 166 followed by 97 followed by 5 followed by negative 2 followed by negative 203, then last but not least negative 2301. That would be the answer, as Mr. K in the comment section has indicated, and we should then be able to comfortably move on to the next question. 166, that's the biggest number, followed by the second biggest, 5, -2, -2003, -2301. So let's just be aware of negative and positive number. This is descending order from big to small. Please guys, if it was ascending order, then we would write from small, we would start with that, followed by this, followed by that, to big. Does that make sense? Hopefully we are all clear now and we don't have that misconception. 2.2, the next question. Okay, calculate the following without a calculator. Calculate the following without a calculator. I'll be doing paper 2 after I'm done with this particular paper. Immediately after I'm done with this paper, I'll be stepping into paper 2. Okay, those who are asking grade 9 paper 2, immediately when I'm done with this paper, I'll be stepping into maths paper 2. Okay guys, here we are not going to be using a calculator. It says calculate the following without a calculator. Right, so what I'm going to be doing here, yes, all right, you can, yes, after I'm done guys, I'll be uploading all of this on YouTube. Okay. Right, so I'm doing this guys for those who are not writing GEC. But even you, if you are going to be writing GEC on the 13th of November, paper 1, you are also welcome to be here, because this is part of the content you'll be covering in GEC. Okay. But there'll be tomorrow morning, for instance, when I do my live sessions at 5:30 up until 7, I'll be doing only GEC type questions starting from tomorrow. All right, yeah, starting from tomorrow I'll be doing only GEC, preparing the kids for what? For the 13th. So -12, the whole thing squared guys. You apply the square. Remember I said an even exponent applied to a negative number gives us a what guys? A positive number. Okay, and then what is 12 squared? That means we are going to have positive 144. Okay, plus, now in brackets we are going to evaluate this. Remember, this is the cube root of -1000. Right, so obviously this is an odd exponent. You could apply this exponent, all right, this root to the -1000, and guys, you will get, obvious, this odd exponent does not change the sign. You are going to get -10. You could take your calculator and put this in there and get the answer. What they're saying here is that without using a calculator does not necessarily mean you don't use a calculator. You could use a calculator to get this answer. You get 144. You could use a calculator to get that answer, because you will get marks for your steps. All right, then this positive times a negative, 144 minus 10. You see this guys, what I mean by that? Okay, so -12, the whole thing squared, is positive 144. Then the cube root of -1000, you could put this in your calculator, you get -10. Okay, right, yeah, remember, even if they are saying without using a calculator, the only way they'll see that this guy used a calculator is if you put everything in here and you simply write the answer. Then they will know that your calculator was used. But the statement that says without using a calculator does not mean that, for instance, to get this answer for -12 squared, you can't use a calculator. You can take your calculator, put this into your calculator, get the answer 144. You will get a mark for that. Take this, the cube root of -1000, put it in your calculator, you get that answer, as long as you show your steps. Then plus times negative, you get a negative answer. Who's not going to give you marks for doing that? Then you see your final answer, 134. They see these steps, they give you all the marks, because they like, this boy or this girl showed us the steps. Does that make sense? I hope it makes sense to you guys. All right, I hope it makes sense. So guys, I'm saying whether you are GEC or not, This is paper 1 content. You are supposed to just be here. All right. GEC learners, I'll be focusing on simply only GEC content tomorrow morning when I do my live sessions. I'll start just only doing GEC up until when you write. Okay. Which is on Thursday. You guys write on Thursday, right? Yeah. All right. So there's the answer. It's 134. Finished. Let's move on to the next question. The next question says 3 to the power negative 2 plus 3 to the power 0 plus 3 to the power 3. Those who are here and you are asking me about other grades, let me just for a moment take a moment here. All right, guys, if you guys go to my YouTube channel, you see on the screen I have a playlist for grade 8 November paper 2 and grade 8 November paper 1. If you guys want to actually prepare for your paper 1 or paper 2, whatever it is, whether you're in grade 8 paper 1, grade 8 paper 2, go to my playlist in my YouTube channel. The link is in my bio. If you haven't subscribed to my YouTube channel, guys, I would advise you to go ahead and do so. All right, yesterday, for instance, I did a live session for grade 8 maths paper 2. I did a whole revision session which was 4 hours and 20 minutes. I did 2 papers, a KZN paper and the EC paper at the same time. You can go there, watch the entire 4-hour live session. I explain things, guys. I unpack things. So if you don't understand certain things, you can just go there and watch. If you are in grade 8 paper 1 or paper 2, just go to my playlist. Make sure when you go to the YouTube channel, okay, if you don't know where the YouTube channel is, just go to my link, go to my bio. The link is there. It's called Maths as a Game. All right, you copy the link. If you can't directly click on there, copy the link, go and paste it on your Google search engine and press search. Then after pressing search, please, guys, go to the YouTube channel, subscribe. Please just do me a favor, subscribe, guys. It's the only free thing you can do for me. Guys are not paying me, but it's for free. You can just do that, and then you can go and watch. Go to the playlists. Grade 8, I have grade 8 maths paper 2 playlist. I have a grade 9 maths paper 2 playlist. I have grade 9 GEC. It's there. Videos, live sessions I did in the past. You can go watch until you become blue in the face. What is nice about me is that when I answer a question, I go and explain to you what the concept is that you may have forgotten when you are being taught during the year. Then you can actually do what? Then you can actually answer the questions. So please go to my playlists, guys. Whether you're in grade 10, there's a playlist for grade 10 paper 1. There's a playlist for grade 11 maths paper 1. There's a playlist for grade 9 maths paper 1, maths paper 2, grade 8 maths paper 1, maths paper 2. Go watch if you know. And today's live session I'll be uploading when I'm done with the session itself. Okay, let's go back to the question that's here. 2.2.2. 3 to the power negative 2 plus 3 to the power 0 plus 3 to the power 3. Without using a calculator, they are saying we must simplify. Okay, 3 to the power negative 2 plus 3 to the power 0 plus 3 to the power 3. So guys, please, we can't just put this in the calculator and get the answer. What we need to do is we need to show the steps. They want to see that we have understood and we can show the steps. So 3 to the power negative 2, we start here. Remember, in exponents, you learned that any base raised to a negative exponent, for instance, a to the power negative 2 is going to be 1 over a to the power 1. A to the power negative 2 is going to be 1 over a squared. So any base raised to the power negative exponent, we take that base, we write it in the denominator. Okay, because currently this base is raised to a negative exponent. It is in the numerator. This is how this basically looks like. It's a to the power negative 2 over 1. We don't see the 1. It is one of the things that's there that you can't see, like the Holy Spirit. So what you do is you take the base a to the power negative 2, you move it to the denominator, and then the exponent changes from negative to positive. What gets left behind in the numerator is the 1 that you cannot see, which is a coefficient of a to the power negative 2. That's why now we have 1 alone. The a leaves the d, the numerator goes to the denominator, and the exponent negative 2 changes to positive. So that's why our answer is 1 over a squared. Look at this one as well. The coefficient is 1 over 1. So what happens when you write this in exponential form with a positive exponent? The a leaves the numerator, goes to the denominator. The exponent negative 1 changes to positive 1. The 1 that is a coefficient gets left behind. The answer is 1 over a to the power 1. So that is what we do with negative exponents. I want to do just one last example. If you have 2a to the power negative 3, what is 2a to the power negative 3? 2 is the coefficient. A to the power negative 3. The base alone, a, is raised to a negative exponent. Therefore, the answer will be 2. Gets left behind because it is not influenced by the negative exponent. The a leaves because currently, whenever you have negative friends that have a negative influence, what do? Maybe 2 is influencing a to have a negative attitude. So what do? You leave that situation, guys. You leave. A needs to leave 2 because he's having a negative influence, giving him a negative mindset. So a leaves the numerator, goes to the denominator, and what happens to the attitude? It changes from what? To negative to what? To positive. So that this would be the answer. I hope it makes sense, guys. So this is how we write negative exponents to become positive exponents. I want to just do one more example. Let's say the situation was like this. 1 over a to the power negative 2. You see, this time around, this a to the power negative 2 is in the denominator. What would happen if we want to express it as a positive exponent? The a leaves because it has a negative exponent. So it must leave that place that is making it to have a negative exponent. It's currently in the denominator. It joins the 1 in the numerator. It becomes positive. Then in the denominator, who gets left behind? The 1, okay, which is a coefficient there that you can't see. So then for the answer is a to the power positive 2. Okay, so let's just apply this rule, guys. Okay, that's how we get negative exponents to become positive exponents. Now come here. So when I write this 3 to the power negative 2, I need to write what is there, 1 over 3 to the power 2. Make sense? 1 over 3 to the power 2 plus. Now what's 3 to the power 0? Any base raised to the power 0. What does that give us, guys? We should all know this. Crown up, thank you so much. It is 1. Any base raised to the power 0 is 1. Any base raised to the power 0 gives us 1. But we must always be aware who is affected. I've seen this, guys. This is very interesting. Learners understand who is affected. 3a to the power 0. What is the answer for that one? Who is affected by the 0 exponent? Is 3 affected? Or is it a? It's definitely a. So 3 stays like that because it's not affected by the 0 exponent. But a is. So therefore we have 3 and the a is 1. So therefore 3 times 1 gives us 3. I hope we understand this. So we always check who is affected by the exponent. Just like for the negative exponent, the 2 is not affected by the negative exponent, but the a is. That's why it is the one that changes the position. Okay, I hope that makes sense, right? I hope that makes sense. So when we have this sorted, then it's fine. Okay. Oh, okay. Hi Gachizo, good to see you then. All right, so 1 over 3 to the power 2, that's correct. 3 to the power 0, that's 1. And then 3 to the power 3. 3 to the power 3. What's 3 to the power 3? That gives us a very good crown up. That's 27. Now we have this 1 over 9 plus 1 plus 27. All right. Now what we see here, guys, is a clear addition of what? Of fractions. You guys learned addition of fractions in grade 8. You should have done addition of fractions in grade 9 and grade 7 as well. So 1 over 9, we can add the 1 plus 27, that gives us 28. But now we have to deal with the addition of fractions. So what do we do when we are adding fractions? We first need to find the lowest common denominator. Very good, crown up. Crown up is like on point there. Then, depending on which method you may have learned at your school, all right, I love to use this method. Since the LCD is 9, what I want to do is make sure that all the denominators have 9 there. So currently the 9 here is there. So that means I can times this by 1 and times that by 1 in order to get the 9 in that denominator. Here, I need to also do the same. I'm going to times here by 9. Why? Because my lowest common denominator is 9. But what I do in the denominator, I have to do where? In the numerator. So therefore that gives me 1 over 9 plus, now what is the equivalent fraction of 28 over 1 when the denominator is 9? What is the equivalent fraction? Obviously in the denominator I'm going to have 9, but what is 28 times that 9? So you should be able to see what? 252, right? Very good. Then what is the rule with addition of fractions? When the denominators are the same, we can now add the numerator, right? So the denominator is the same. That is going to be 9, no doubt. But we can now add the what? The numerators. So what do we get? We get 253 over 9. Okay, as our answer. Right? Now, you can leave that answer in this form as an improper fraction. If they had said leave your answer as a mixed number, then you leave it as a mixed number. Just grab your calculator quickly and check. What is 253 divided by 9? Just check from your calculator if do you get a simplified fraction, or is this basically the most simplified that your answer can be. Take your calculator, your scientific one, and say 253 divided by 9. We don't want to express this as a decimal. We don't want to, because if we express it as a decimal, remember, then it will appear that, oh, they used the calculator. We want to leave this as a simplified fraction. So the question is, when you type this in your calculator and you say equal, do you get a simplified fraction, or is it simply just that? Okay, thank you so much, Crown Up. Thank you so much, Crown Up. So it's 253 over 9. That is the answer. Guys, step by step. You see, step by step. We do not sabotage ourselves and simply put this in the calculator and write the answer. Writing the answer only will lead to a loss of marks. But if we can show our steps, then our marks, we will definitely get all of them. Okay. Right. Let's move on to the next question. Now we are entering into the world of ratios, interest, and proportion. We're moving to what? To the world of ratios, interest, and proportion. So 3.1, write the following ratio in its simplest form. Write what? The following ratio in its what? In its simplest form. We have 6,4 is to 4 is to 4,8 is to 5,6. Now the thing is, guys, we need to just establish firstly, what is a ratio? A ratio is the comparison of two quantities of the same type. Say that again. Ratio is the comparison of two quantities of the same type. So if we have there, what we can see, we have 6,4 is to 4,8 is to 5,6. We have three quantities that are basically being compared, and they are of the same type. They are in decimal form, all right, and there's three of them representing that ratio. But we know that when we are dealing with the ratio, we'd rather have whole numbers that are actually the quantities that are in that ratio. That makes simplification so much more possible. So to simplify that ratio, we want to basically convert those decimals into whole numbers. So there is something that we can do, which is we can apply to all of those quantities so that we get them all to become numerical values that are not decimals. So if you look at 6,4, look at 4,8, look at 5,6, the decimal place that they are in, all of them, is the first decimal place, 3.1. The decimal place that 6,4, 4,8, and 5,6 are in is the first decimal place. What we want to do is actually now get all of these quantities to be in the same decimal place that basically allows us to have them as whole numbers. So how can we do that? How can we change 6,4, 4,8, and 5,6 so that they are whole numbers? Okay. What we will do is we will move the decimal one place to the right. What does that mean? We are going to multiply, as Takis said in the comment section, we are going to multiply each quantity so that it becomes a whole number by 10. All right. Or let me say whole number or integer, because sometimes these numbers can be negative as well. But if they are decimal numbers that are negative, that means we are going to have to convert those decimal numbers to become what? Integers. So it's very important here, the conversion. So when you ever find yourself in a situation where the numbers are decimal, it becomes your responsibility to take that decimal conversion so that you get those individual quantities into integers. So you check the decimal place that those numbers are in. Currently, this is all one decimal place. 6,4, 4,8, and 5,6. So if we multiply by 10, what happens to 6,4? It becomes 64. Okay? Yes. What happens to 4,8? It becomes 48. What happens to 5,6? It becomes 56. Now, I'm sure when you look at the ratio again, you are like, I think I can simplify now, right? You think you can do what? You can simplify. Remember, guys, if let's say this is the equivalent form, this 64 is to 48 is to 56 is the equivalent form of this ratio, right? So really and truly, the essence of this ratio is still maintained when we multiply by 10. It's just that we've moved the decimal place one to the right. That's all we've done. Why? So that we can then facilitate the simplification of the ratio. Now, step number 2. After the decimal conversion, we've multiplied by an appropriate, base 10. Now what do? We find the highest common factor between these three, right? No. Bam Bobby. we are multiplying by 10 because we can see that all three of these ratios are in the first decimal place. So since they are in the first decimal place, how do we then convert this decimal to become an integer? These quantities to become integers. It means we can move each individual quantity to one decimal place to the right. So that means we timesing by 10. To move it one decimal place means we times by 10. All right. Yeah, because we could be given something like this. For instance, okay, because remember guys, we could be given decimal places. Maybe it's in the second decimal place, maybe it's in the third decimal place. Remember, if we were in the second decimal place, then we would actually do what now? We would multiply by 100. If all three of our quantities were in the second decimal place, we'd multiply by 100. If all three quantities were in the third decimal place, we'd multiply each quantity by 1,000. So we always multiply by that particular base 10 power that will actually lead to a whole number for all three of these quantities without necessarily changing the equivalence of the ratio, because the ratio is still basically fundamentally the same. All right, then now what do we need to do? Between 64, 48 and 56, we need to find the highest common factor. Now I'm expecting that you guys know how to find the highest common factor. By now you should, because in grade 7 you learned how to find the highest common factor. In grade 8 you learned how to find the highest common factor. You are in grade 9 now, so you should know how to find the highest common factor. All right, so for me, the method that I use that is very quick to find the highest common factor is simply to do what? You need to, you can use the prime factorization method. All right, so since you are in grade 9, you have your calculator. You can simply take your calculator and say 64 is equal to shift fact. All right, what do you get in your calculator? Please tell me. Do the same thing with 48. 48 is equal to shift fact. Tell me what you get for 48, and then you can take 56 and say 56 is equal to shift fact, and then you tell me what you get. So for 64, crown up got 2 to the power 6. Hopefully we all got that. You can take 48 is equal to shift fact and tell me what is the product of prime factors that you get for 48. Thank you, crown up. Crown up is really helping me there in the comment section. And then you can take 56 and do the same. 56 is equal to shift fact. Okay. This is departing from using the ladder method. Some of you used the ladder method to get what we call the product of prime factors. What do we mean by the product of prime factors? Those prime numbers that you multiply together to get 64. So 6 2's multiplied together will give me 64. That's the prime factors multiplied together that give me 64. 4 2's times 1 3 gives me 48. Now let's go to 56. What's the product of prime factors for 56? Product of prime factors for 56. 56 is equal to shift fact. Okay, let me help you out. 2 to the power 3 times 7, because 8 times 7 is 56. So 2 to the power 3 times 7, that is it. Then, how do we identify the highest common factor? We say from this, after writing the product of prime factors, we choose the common base with the lowest exponent. We choose what, guys? The common base with the lowest exponent. So we are going to look at all three and choose there the common base with the lowest exponent. Okay, so let's look at this. 64, 48, and 56. Which base is common? 2 to the power 2, 2, 2. So the base 2 is common. Which one has the lowest exponent? It is 2 to the power 3. So it becomes chosen. Okay. Now, if you look at 3, is 3 common? No. Is 7 common? No. Guys, it must be common for all 3 bases. When I say common, it must be common for all 3 bases. But this only applies for HCF. For LCM, it's a bit different. Okay? Now, if, let's say, for instance, 3 was common as well. Let's say 3 was common as well. We would choose that base for 3 that has the lowest exponent. Then what we would do is we would multiply it with the 2 to the power 3. And then that multiplication would give us the actual highest common factor, okay? If 3 was common, okay? We would multiply all the ones that are common and then write down that answer. So in other words, that means the highest common factor for 64, 48, and 56 is actually 8. That is the highest common factor. Okay, so those who don't know how to find the highest common factor, guys, it's simple. Use your calculator, all right? Take each individual number, write each individual number as a product of what? Of prime factors. Then after doing that, what do? You actually choose the what? The common base for all 3 bases with the lowest exponent. And then you would write the product of those common bases, and then you would get the answer. But here currently, we only have one common base that has the lowest exponent. So that's 2 to the power 3. So therefore, the highest common factor between 64, 48, and 56 is 8. Okay? No. I won't do this later. You can watch the video when I upload it onto my YouTube channel, or make it a point, you go and subscribe to my YouTube channel. Link is in my bio. Copy and paste. Copy the link, paste it on your Google search engine, press search, go to the YouTube channel, subscribe, and then when I upload, make sure you hit the notification bell so that when I upload, you can get a notification that I've uploaded this video. You can rewatch it at your own time. Okay, so those who are on the run, don't worry. Okay, we have the highest common factor. So step 2, we find the highest common factor. Crown up, listen to me. Okay, since we are here, let's just look at the concept of LCM. Crown up. Crown up is bringing up something else. Now, crown up is asking now about what about the lowest common multiple? So let's say they were asking us to find the lowest common multiple between 64, 48, and 56. Since you asked, crown up, good question. Let's say they asked for the LCM. All right, now I'm just on the side, guys. Please, this is not me answering the question that we were being asked to simplify. I'm just trying to answer the question that is in the comment section. How do we find the LCM? How is it different from finding the HCF? Now, you still write these numbers as a product of prime factors. Okay, so as a grade 9 learner, you can do this. Write the product of prime factors using your calculator. You know, you press 64 equal to shift fact, boom. 48 equal to shift fact, boom. 56 equal to shift fact, boom. Ne? So you have your product of prime factors. Then from there, listen to me, you choose the common base with the lowest, no, not the lowest, sorry, the highest what? Exponent. Now listen to me, this common base with the highest exponent doesn't have common base with the highest exponent. So let's come here. Come. Which one is the common base with the highest exponent? So common base here with the highest exponent is what? So 2 is common. 2 to the power 6. That is definitely there. Okay. because it's common for all three. But with LCM, we do something slightly different. That is, all the leftovers, L for lowest means L for leftovers. So that means we are going to check 3, right? Okay, but let me just say this. I think let's make this very easy. For lowest common multiple, guys, we choose the common base with the highest exponent, okay? Now, 2 is common, all right? So we write 2 to the power 6. So we are done with 2. We move on to the other bases. So with lowest common multiple, we also check the other bases, even if they are not common for all 3. And let's say that here, since we have 3, that means we are going to include 3, because 3 is the only base that is there for base 3. Right? But let's say there was 3 here, and let's say here there was a 3 to the power 2. Okay, let's just say for argument's sake, guys, I'm just putting this here. Let's just say we had this first number, it had these prime bases. We had this second number, it had these one, and then we had this third number, it had this there. I want you to listen up. For LCM, obviously, we choose the common base with the highest exponent. So, of course, for base 2, we'll choose 2 to the power 6. But we go on to base 3. Base 3, even though it's not common for all bases, but here is base 3. Between the two, we are going to choose the one that has the highest exponent. So it's going to be 3 to the power 2. So for lowest common multiple, as long as that thing is common, and if it is unique, we are going to take it. So for 3 and 3 to the power 2, we know it's not common for all 3, but you know what? We are going to look at these 2 and choose the one that has the highest exponent. Then look at 7. 7 is alone. So we are also going to take 7. Okay, we take even the leftovers. By leftovers, guys, I usually mean the ones that don't have a common base. It's there. We take it. For highest common factor, we don't take leftovers. But for lowest common multiple, we look at everything. 2 is common for all 3. 2 to the power 6. We take the one that has the highest exponent. 3, base 3 is not common for everything. But you know what? We take the one that has the highest exponent. 7 is alone. Okay, it is not even common, but it is alone. We take it. And then from there, we can write what the LCM is. So I hope it makes sense, guys, what I mean by when we want to write down the LCM. Everything here, we multiply together. That would be 64 times 9 times 7. We would get that LCM for whatever that number is that we have there. Okay. Does that make sense, guys? I hope it makes sense. So here for this one, okay, base 2, base 2, base 2, common, we take the one that has the highest exponent. 3 is not common, it's unique, we write it there. 7, not common, it's unique, we write it there. So our LCM would be 64 times 3 times 7. You use your calculator, you get the LCM. So that is the difference between getting the LCM and the HCF in grade 9. Right? Okay, makes sense? Right. I hope you are clear, guys, because for me, it's important that you are clear. If you are clear, then you will have no misconception. And if you have no misconception, it's so beautiful to write. Okay? Okay, so that whatever that answer is would be the LCM. Okay, so let's go back to the question. We wanted to simplify this ratio. Okay, we said 6,4, 4,8, and 5,6 are decimal numbers. They are on the first decimal place, all 3 of them. So we need to first convert the decimal to become integer values. This 6,4, how can we get it to become a integer number? Okay, we multiply each quantity in our ratio by what? By 10. Why? Because they are all in the first decimal place. If we move the decimal place over by 1, that becomes 64. Move the decimal place over by 1, becomes 48. Move decimal place by 1, becomes 56. That's multiplication by 10, the conversion of decimal to integer. 2. Find the highest common factor between what? 64, 48, and 56. It's easy to find the HCF between integers. So we find the HCF, as I said, you take 64. 64 equal to shift fact, you get 2 to the power 6. That's the product of prime factors for 64. Take 48. 48 equal to shift fact. Guys, you don't have to write this down in your workbook when you're answering. All we need is these numbers. You just need to write 64 equal to 2 to the power 6. 48, 2 to the power 4 times 3. 56, 2 to the power 3 times 7. I'm just showing you this so that you know what to do. Right? Because usually you used to use the letter method to get these values, but now you can just simply use your calculator in grade 9 and get 2 to the power 6 for 64, 2 to the power 4 times 3 for 48, 56 is 2 to the power 3 times 7. So when you have these, then to get your HCF, what do? You choose the what? The common base with the what? With the lowest exponent. And this common base needs to be common for all 3 bases. So 2 to the power 6, 2 is common. Base 2 is common. Then we choose the base with the lowest exponent. Which one is it? It's 2 to the power 3. 3 here as a base, okay, is not common. 7 as a base is not common, so we don't write it as a product, because we need, when we write down the HCF, to have the base that is common for all 3 bases. That's what we need to write down for the HCF. So it's 2 to the power 3 only, which means the highest common factor is what? Is 8. That is step number 2, finding the HCF. Sometimes people don't even need this method to find the HCF. They know from their heads what the HCF is. If you can do that, great, guys. Great. Especially for when you have to simplify a ratio. Okay, it's a different story when they are saying determine the HCF. Then you need to show your steps. Okay, but here we simply are simplifying a ratio. Now, once we find the HCF, step number 3, divide each quantity by the HCF. So what we're going to do, we take 64, divide by 8. We take 48, divide by 8. We take 56, divide by 8. Then we get an answer for our ratio, which is what? 8 is to what? Is to 6, is to what? Is to 7. There it is. The ratio has been simplified. Okay, and you said simplifying ratio is difficult. No. Simplifying ratio is easy, guys. It's not difficult. Okay, so especially when it is a decimal number, this is how we go about it. Okay, in most cases you get your numbers, all right, and you need to simplify in the HCF. Okay, most cases it's not even given as a decimal. You get the numbers and all you need to do is find the HCF. Because you already have the integer values, you just find the HCF and then you divide and get the answer, and that is it. Okay, right? Any questions around ratio, specifically this one? You're welcome, Crown Up. Okay, I can see you there. Yeah, very active, Crown Up, very Crown. Shakura, you're welcome. Okay, let's move on to the next one. 3.2. We have Anna, Leti, and Emily. Anna, Leti, and Emily invest in a business in the ratio 1:3:5. Anna, Leti, and Emily invest in a business in the ratio 1:3:5. If the profit is 450,000 Rand, how much does Emily get? Okay. You can see more, you can always check it on my YouTube channel. I won't be repeating that question that I just did. I'll be uploading this video though in the YouTube channel. You can always check it out. Okay, real 27, I see you. But remember guys, we need to show the steps. Okay, so when we do these questions, it's grade 9, Hamlet, it's grade 9. But applicable to grade 8 because you also do this. Anna, Letty, and Emily invest in a business. Yes, crown up, very good. The first step we need to do there is we need to add the ratios. Okay, yeah, step 1. Okay, you check there, we have to add the quantities in the ratio so that we can get our parts. Okay, so 1 part, so 1:3:5 simply means we take 1 part, we take 3 part, and then we take 5 parts, and that gives us what? 8 of those parts. So I'm just kidding, man, not 8, 9 of those parts. Thank you so much there for the correction. 9 parts, guys. 1 part plus 3 part plus 5 part gives us 9 parts. Okay, that's the first step. We add the quantities in our ratio. Then after that, remember, 1 part is given to who? Anna gets 1 part. Who gets the third? Who gets 3 parts? It is Letty who gets 3 parts. And who gets 5 parts? It is Emily. Alright, so we are being asked, how much does Emily get? So we are interested in how much Emily gets. The question, when it is direct and specific, we need not waste time. Okay, we need not drag the question. We are being asked there to, how much does Emily get? 1 part is for Anna, 3 parts is for Letty, and 5 parts is for Emily. So Anna, Letty, and Emily invest in a business in the ratio 1:3:5. So 1 part belongs to Anna, 3 parts belong to Letty, 5 parts belong to Emily. In total, they have 9 parts. But how do we figure out how many parts does my good friend Emily have? This is very important because that in itself is what we basically need to find. So we are interested in Emily, the 5 parts for Emily. Does that make sense, guys? So then what do? We take the 5 parts. So we want to find out how much money will Emily get from this. We take the 5 parts that Emily has. We then divide it by the total number of parts, which is 9. Then we times that by what? By the total amount of money, the profit, which is how much? 450,000. Then Mr. Calculator should come here and serve us very well. Just grab your calculator, right? You go to this option, you go plug in 5 and 9, and then you times it by 450,000. This is in your calculator. Just make sure, guys, that the zeros, always make sure, because sometimes people will put 45,000, they'll get an answer that doesn't make sense. Please make sure you've put the number of zeros that need to be put. Just be careful when you are using your calculator that you double check that whatever you wanted to type from your question paper is exactly what you see appearing in your calculator. Then you get an answer. I see people have answered 250,000. Emily is getting the lion's share of the profit, because he's getting the highest number of parts. Okay, 5 parts of that 450,000 belong to Emily. So 250,000 already, guys. You can see this is more than half of this profit that Emily is grabbing. So one day when you decide to start a business, hopefully you have the biggest share of the parts, or the biggest ratio. I mean the biggest quantity in the ratio, so that you can actually profit a whole lot more. Yeah, so Emily gets this amount, guys. That's the amount, 250,000. That is it. Done, finished. Okay, let's move on to the next question. 3.3. We've got Mr. Jan there. Jan borrowed 10,000 Rand from the bank at 9.5% compound interest per annum. For how long? For 3 years. How much money must Jan pay back after 3 years? How much money must Jan pay back after 3 years? So we have two types of interest that we are particularly looking at in grade 9, and that is simple interest and compound interest. Of interest to us is the two formulas that basically make up these two, right? We have two formulas for compound interest related calculations. Compound interest, we use this formula: A is equal to P 1 plus I to the power n. For simple interest related calculations, we use this formula: A is equal to P 1 plus I times n. The A is the future value or the amount of money after some years have passed. P is the present value, or it is the amount that you invest now if it's an investment, or that you take out as a loan at the beginning. N is the number of years. I is the interest rate expressed as a decimal number. So we usually take that percentage and we divide it by 100 to get the interest rate as a decimal number. So I repeat, A is the accumulated amount, future value after a number of years. P is the present value, or it is the present amount, the principal amount, the amount you invest at the beginning, or the amount that you take out as a loan. N is the number of years. I is the interest rate that you convert, which is R, from a percentage to a what? To a decimal number. Okay, so we are being asked in this question: Jan borrowed 10,000 Rand from the bank at 9.5% compound interest per annum for 3 years. So what we do first and foremost, we first ask ourselves, what type of situation is this that we are looking at? Is it compound or simple? So it's very clear from the situation there that we are talking about compound interest. So you write down the formula: A is equal to P brackets 1 plus I brackets to the power n. So you identify first, read the statement, identify the type of interest. Very important. And calculation that you need to be busy with. Then 2, you need to then write down A, P, I, and N. Right? You remember someone saying it's P, A, I, N. You know, usually people will say that finances bring pain. P, present or principal amount. A is the accumulated amount. I is the interest rate, and then N is the number of years. Money brings pain. Pain, when you don't have it, it brings a lot of pain. When you are in debt, it brings a lot of pain. It brings a lot of headache, pain. So make sure that you have the P, the A, the I, and the N. So A, what is A? A is the future value. That's what we want. Put a question mark. P, as Crown Up said in the comment section, that becomes 10,000. The amount Jan borrowed. Jan borrowed how much? 10,000 Rand. So the borrowed amount for a loan, because in the case of Jan, we are talking about a loan. Okay, you can have two situations. It's either you take a loan and when you pay it back, it has basically accumulated interest, or you invest, meaning when you invest, you are saving. So here we are saving when you are investing. Okay, but a loan, right? Remember, when you take out a loan, at the end of the day, who's going to benefit? The bank, because you are going to be paying them back their amount plus interest. When you are saving, who's benefiting? You, because when you save, you put away money so that in the future you can have money. All right, you use the interest that the bank gives you to make more money. So I is the interest rate as a decimal. What did I say, guys? That interest rate, we take that interest rate, which is R as a percentage, We divide it by 100. Very good, crown now. Then we get what? 0.095. Okay. Then lastly, n, the number of years. We are told there for 3 years. 3 years. Okay. So that's why I'm saying we first identify the type of calculation. Then we write down the formula. 2, you then identify the A, P, I, and N. Pain. Alright? And then 3, you substitute where? In the formula. You substitute where? In the formula. Let's go substitute in the formula. So A is equal to 10,000 into 1 plus the I 0.095 to the power what? 3. And then it's simple from there, guys. We just use the calculator to find the value of A. So I'm waiting for you to tell me what is the value of A. As it says in the question. $10,000. Okay. Brackets. 1 plus 0.095. You close the brackets to the power 3. Okay. So what is the answer then, guys, that we get here? You don't have a calculator, you better get one then. You better get one. Surely you have friends in other grades in your school. Please get a calculator. Or make sure mommy dearest makes a plan to get you one. Okay, there it is. The answer is 13,129 rand 32 cents. There it is. Okay, you round off, okay, guys, to 2 decimal places, because the instruction, if your calculator, please guys, make sure you round off to 2 decimal places. If they didn't specify the decimal place, you always round off to 2 decimal places. Why? Because in the front cover of the instructions, they say round off to 2 decimal places unless stated otherwise. See, there we round answers to 2 decimal places where applicable. Okay, always check the instructions before you even answer the question paper. I always check the instruction, what it says at the beginning of the question paper, because they might change it and say maybe in the instruction round off answers to 1 decimal place, and when you always use to 2 decimal place. So always check the instruction, and always check the instruction of the specific question. The next question says, calculate the interest after 3 years. The what? The interest after 3 years. This is a beautiful formula that I like to calculate the interest. Okay, so the interest, because what they want here is they want to discover the bank must give you a loan of how much? Of 10,000. After 3 years, what happened? You now have to pay back to the bank after 3 years 13,129 rand 32 cents. So the question is, how much interest did the bank actually make from this giving you the loan? Okay, so the A value, which is that, is 13,129 rand 32 cents. Don't forget that 32 cents. So you are going to subtract 10,000 from that, which is that loan amount that they gave you at the beginning. What do you get? That is the amount that they want. They want to check what is the interest that basically the bank was able to make. Okay. Yeah. So when banks give you a loan, you must know that they are intending to make money from you. You know, it's not the other way around. When you take out a loan, the banks will make money. But when you invest and save, you are making money using the bank. So the answer is 3,129 rand 32 cents. So that is the amount that the bank made by giving you a loan of 10,000 rand. After how many years? After 3 years, right? So the interesting thing, guys, grade 9s that are here, these calculations that we are doing here are the same calculations that the grade 10s in pure mathematics are doing. So if you are intending to do pure maths next year, Please, guys, if you're intending to do pure maths next year, I'm intending to have a consistent academy for the grade 9s. Not really an academy, but like, I don't want to use the word academy. I want to use another word that's different. I'll figure it out what that word is. But I want to help those learners that need help, but it will obviously come at a price. So if you are someone who's here and you're intending to do grade 10 maths next year, you want to do grade 10 pure maths, not maths lit, but pure maths, and you want to maintain a performance of 85% and above, or 90 and above, or 100%, whatever mark you want to get that's above level 7. Nowadays, when you do pure maths grade 10, you must aim for 85 and above. Just get that mark. It's possible. Those learners that want that for themselves next year, we can start even during this holiday. It will come with a price though. You just need to alert your parents. Let your parent know that you were in my live session. You probably learned a lot, or whatever the case may be, and you'd want to basically be part of this thing. Okay, it will be reasonable. I won't be charging very high prices, but I need your parent to be involved. I need your parents' consent. I need your parent to basically be the driver and someone who commits that this will be like that. Then we can have a WhatsApp group for those particular learners, all right, that have also indicated their interest and basically have paid that particular amount, which is, like I said, it will be very, very minimal. And then what we can have then happen is that I will be assisting those learners throughout the year, all right, from making sure that the syllabus, whether you are taught at school or not, you will have the syllabus covered. I will cover the syllabus with you. We will start the syllabus even before the syllabus starts at your school, and we'll cover the things that need to be covered. By the time you enter term 1, my leader, you will be so fit, it will not even be fun. You'll be able to get the marks that you always have felt you deserve for mathematics, and you will not ever have to blame the fact that you are not taught at school, because I'll be teaching you whether you are being taught at school or not. You'll end up teaching other learners at your school. I can promise you that. So if you are here and you are in the live and you're going to be doing pure maths next year, you want to you maintain excellent marks, 85% and above, 90, 95, then please, guys, do contact me on the side, and we can see what arrangement we can make, because already in the December holiday I'll be starting with that group of learners. That's for grade 10, right? Also grade 11, and also those who are in grade 12. So that is something that I'm intending to do in this coming year for the grade 10 learners. Okay. All right, I think we're done with this question. Let's move on, guys. Let's move on. Okay. Right. 3.4. Okay. All right. 3.4. The following table shows the time it takes for a train to travel a distance of 300 kilometers at different speeds. Now, speed. You can see the speed, which is in kilometers per hour, 30, 40, 60 y. Then time, 10, 7.5, x, and 3. 3.4.1 says, does this data form a direct or inverse proportion? In other words, is this direct proportion or indirect proportion? Now, let's first just be clear about what, again, is direct proportion versus indirect. Direct proportion, guys, is simply this. It is it is basically when we compare two quantities that are not the same type. But what do we notice about it? As one quantity increases, the other also increases. That's direct proportion. It's a comparison of two quantities that are not the same type, but what do we notice about them? As one quantity increases, the other increases, or as one decreases grade 9's paper 1, yes, the other also increases. The other also decreases. So if you look at this comparison, you will have one quantity on your y-axis and the other one in your x-axis. This is usually the situation. It can either be a situation like that, as one quantity increases, the other one also increases, or a situation like that. Okay, as one quantity as one quantity increases, the other one increases. Okay, so graphically speaking, usually that is the situation. Sorry about that. You increase, I increase. All right, that is usually the situation of direct proportion. All right, direct. Okay, then we say the ratio between the quantities is constant. Okay, this is a very big thing here. The ratio between the quantities is constant. That is direct proportion. What about indirect or inverse? The word indirect or inverse means the same thing, so that would be the opposite. We are comparing two quantities as well here. Obviously, these two quantities are not the same type, but with them, what do we notice? As one quantity increases, the other decreases, or vice versa. Okay, all right, let me just say or vice versa, because if I'm going to write all this, it's going to be too long. Okay, I hope that makes sense. One quantity increases, the other one decreases. Okay, so I hope that makes sense. Then we say the product between the quantities is constant. So this is what defines or differentiates this guy from that. The product between the quantities is constant. Okay. The product between the quantities is constant. So for indirect, it's the product between the quantities that is constant. But for direct, it is the ratio between the quantities that is constant. In other words, the ratio. Remember, ratio can be written like this. You can say A is to B, or you can say A over B. This also means ratio, guys. Fraction, remember, the word ratio comes from the word rational. Or let me say, rational comes from the word ratio. The word ratio means fraction, where A and B are integers. Okay, I hope that makes sense. So let's go back to that situation. Look at speed. Speed is one quantity. Look at time. Time is another kind of quantity. Speed, what are you seeing with speed? We're going from 30 to 40 to 60. So what's happening to speed? As we move from left to right, we are having a what of speed. What's happening? Is it increasing or decreasing? 30, 40, 60. Okay, 30, 40, 60. Is speed increasing or decreasing as we move from left to right? The quantity is there, 30, 40, 60, right? I hope you can see it's an increase in speed. Look at time. Time in hours. We have 10, 7,5, then the x, then there's the 3 at the end. What's happening with time? Is time increasing or decreasing? Decreasing. So what does that then mean, guys? Does this data form a direct or inverse proportion? If one quantity, speed, is increasing whereas time is decreasing, which relationship are we seeing here? Are we seeing data that is direct proportion, or is it inverse proportion? Okay, there are two things here. It can either be direct proportion or it is inverse or indirect proportion. Here they use the word inverse, but remember, inverse means indirect proportion. Okay, so I am happy that all of us see that it is inverse. It can't be direct. Okay, because remember, by definition, what did we say is direct proportion? We said it's the comparison between two quantities that are not of the same type. And what do we see by it? As one quantity increases, the other increases. Or we can say as one quantity decreases, the other decreases. Whereas for indirect or inverse, it says as one quantity increases, the other decreases, or vice versa. As one decreases, the other one increases. Okay. Okay, so hopefully we understand. Guys, the answer there, we would write inverse proportion, not direct, inverse, because we understand what inverse and indirect mean. Now, let's move to the next question. The next question says, determine the values of x and y. Determine what? The values of what? Of x and what? And y. Okay. Now, if you look at the question itself, it says, the following table shows the time it takes for a train to travel a distance of 300 kilometers at different speeds. Now, depending on who's answering the question, there are two ways you could answer this question. Okay. So I'm going to first approach this question the way that we would answer it if we were approaching it in the direct and indirect proportion understanding. Now, since we know here that this is an inverse relationship, I'm just going to do this. I'm just going to rewrite my values here. Okay, these are my values. This is speed in kilometers per hour, and this is time in hours, of course. All right, so what's nice is that the quantities here, this is kilometers per hour as it should be, and this is in hours as it should be. So our units are fine. All right, they are different. As we said, we are comparing two quantities that are not the same type when we are talking about this. Okay, so if we look at this, guys, we need to actually show our steps here. So we want the value of x, right? You remember I said to you guys that for indirect or inverse proportion, the product between the quantities is constant. What do I mean by the product between the quantities is constant? This basically means the following. If I want to solve this thing, I want x, so I'm interested in this column. I'm interested in 460 and x. And then if I look here, guys, it doesn't matter which one I choose. I can choose 30 and 10, or I can use 40 and 7,5. We already established that this is an inverse proportion, right? So I already know that the product between the quantities, this is important. My understanding of inverse proportion is that the product between the quantities is what? Is constant. So in other words, if I take this column, this 60 and this x, I can say 60 times x. Why am I saying 60 times x? It's because the product, what does product mean? It means multiplication. The product between the quantities is constant. What does the word constant means? It means the product between the quantities is the same. So I can say 60 times x. This is one quantity of speed times one quantity of time is equal to I can take either this one or that one. It's really up to me which one I take, guys. It's really up to me. I can say 30 times 10. The reason why I use this, or I can use that, is because I know that the product of this and that will be the same product of this and that, because it comes from my understanding of the inverse proportional indirect proportion, that the product between the quantities is constant. So look at this. I said 60 times x, using this understanding, is equal to 30 times 10. All right, this basically means 60 times x is 60x and 30 times 10 is 300. Then what do I do? Here I can now divide. Divide by what, guys? Divide by 60. Okay, divide by 60. Okay, because the coefficient of x is 60, I divide by 60 both sides. Then what do I get for x? X is equal to what? Okay, thank you very much. It's 5. Okay, it's 5, guys. X is equal to 5. Now I want to show you that if I wanted to, all right, okay, I just wanted to show you, if I wanted to, I could have used these values, maybe not this one, but these two. Okay, I could have done the same thing and said 60 times x is equal to 7,5 times 40, or 40. Okay, 40 times 7,5. Okay, done the same thing here. All right, I want you to see that if I wanted to, I could have said 60 times x is equal to 40 times 7,5. Why? Because I understand that since this is inverse proportion, the product between the quantities is constant. So I can use this product and that product. It is constant. It is the same. So I get 60x is equal to, what's 40 times 7,5? What's 40 times 7,5, guys? It's still 300, right? You see, I just want to dispel in your head. Had I decided to use any other, I would have still gotten 5. Now remember, that x represents time, so I need to make sure I write the quantity and its unit. Okay? Please, guys, this is so important. So I want you to understand the concept of indirect proportion, that it is the comparison between two quantities not of the same type, but as one quantity increases, the other decreases. So that's how you pick it up. Once you pick up its inverse, then you know that the product between the quantities is the what? Is the same. So therefore that means if you want to calculate the value of x and you want to show your calculation, this here is very big. The product between the quantities is constant. It is the same. You can say 60 times x. You can equate it with 30 times 100 times 10. And you can solve for x and get x is 5. Or if you wanted to, you could have said 60 times x is equal to 40 times 7,5. And then you would have gotten x is equal to 5 hours. Does that make sense? I hope you are clear there. Now, let's go for y. We want the value of y. What do we do if we want the value of y? Well, still, this is an inverse proportion type relationship. We want y. So what we can do is we can use any of these columns and say y times what? We know that the product between the quantities for inverse proportion is constant. So we say y times 3. We follow the order, y times 3. We start at the top, we multiply with the bottom. we start at the top is equal to 40 times 7,5. We start at the top, we multiply at the bottom. Makes sense? Then we solve for y. Y times 3 is 3y. Then 40 times 7,5 is obviously 300. Then what do we do from here? We divide by the coefficient. What do we get? Y is equal to 100. Okay. Does that make sense, guys? Simple, straightforward, to the point. Now, guys, I want you to listen to me and listen to me well. Let's say that the relationship did not give us an inverse proportion, but it was direct proportion. Let's say we had discovered that as one quantity increases, the other one also increases. Then, guys, we would have not done the same thing of multiplying, because it's only for inverse proportion that the product between the quantities is the same. For direct, we don't say the product is constant, we say the ratio is constant. So what would I have done in that situation if it was direct? I would have said y divided by 3. I would have written this as a fraction and then say 40 over 7,5. Then I would have solved for who? For y. You see? Yeah. If it was direct proportion, we wouldn't have said the product between the quantities is constant and set up an equation using product. We would have set up an equation using ratio, which means we would have said this divided by that, this over that is equal to this over that. So that's what's important here. So that's why it's important to understand what type of proportion are you dealing with. All right. Yeah, that's just so that you guys know that it becomes a different story when it's direct proportion. Okay, so I'm just going to do an example for direct proportion, since people are asking me in the comment section where to do so. All right, just quickly, let's just say we had a table like this. Right, so I'm doing an example for those that let's just say we had this. Okay, bye Crown. Thank you so much for joining in. So let's just say we had these two quantities. Let's say we still had distance and time, just for argument's sake. Then we had this situation. If you look at the top, 1, 4, 12, 2, 8, 32, you can clearly see that we are increasing here. We are also increasing here. So if we are increasing with this quantity and we are increasing with this quantity, that obviously means we are dealing with a direct proportion, not an indirect proportion. We are dealing with a direct proportion. Okay, so that's the first step. Okay, this one's different from this one. Here, this one is increasing at the top, this one is decreasing at the top. We are not dealing with a direct, we are dealing with an indirect or inverse proportion. And remember, for inverse proportion, we know that the product between the quantities is constant. That's why we used product to get the value of x or y. Now here, we are dealing with a direct, because as one quantity increases, the other one is also doing what? Increasing. So what do we do now? We want the value of x, we want the value of y. What do we know about direct proportion? We know that the ratio, what is this? The ratio between the quantities is constant. If I could say it maybe in layman's term, I would say the division for ratio, the division or the quotient, let's use mathematical terms. The division or the quotient. Quotient means division. Division means quotient. The ratio or the division between the quantities is what? Is constant. So let's come here. We want x. So now what are we going to do? We are going to say x over 32. Are you listening to me? X over 32. This is division. X divided by 32. So I move in the same direction from here to there. X divided by 32. Then I can choose any of the ones that I have. 4 over 8 is equal to, if we started at the top, at the bottom, we start at the top, 4 over 8. Then now I can do what? I can solve for x. Guys, solving for x here is very straightforward. Okay, 32 here is your denominator. 32 and 8. You know that the LCD between 32 and 8 is 32. Alright, so what you can then do is you can multiply both sides by the LCD. You see, for an equation, you use your LCD to eliminate the denominator so that you can solve for x. So you can cross multiply, which is basically the short form of using the LCD and multiplying each fraction by that 32. So if I multiply by 32, I multiply in the numerator. What I do on the left, I must do on the right. So this 32 and this 32, they cancel. That leaves me with 1 and 1, which means I have x on the right, on the left, sorry. Then I can take my calculator, 4 times 32, and then I divide it by 8. What's 4 times 32? Or you can say 4 over 8 times 32. Okay, so that gives you what? I hope you see that the answer that we get there is, did you get 16? I hope you understand that we get 16. I'm not having a class for grade 8 today, so if you want to watch anything grade 8 related, whether it's paper 1 or paper 2, in fact paper 2 related stuff for grade 8, I've uploaded on my YouTube channel the session I had with the grade 8s. You can go to the grade 8 maths paper 2 playlist. It's there. 4 hours and something minutes, because that's how long it took for me to complete that session. Okay, so yes, so x is equal to 16. Let's say we want to find y. Okay, then please guys, if we want to find y, let's move in that direction. Remember, we are dealing with direct proportion, so the ratio between the quantities is constant. The division or the quotient is constant. Username is Maths is a Game. It's the same thing, guys. Maths is a Game. The link is in my bio, guys. You can go to the bio. Okay, I have 2 links there. There's the WhatsApp channel. Forget about it. Go to the YouTube channel. Copy the YouTube channel link in my bio. Paste it onto the Google search engine and search it, and you'll find the YouTube channel. Subscribe, and then also you can go to my like I said, go check out that. So we want y now. So what we are going to do, we are going to make it so that we start with the y in the numerator. So you say y over 12 is equal to, remember we started at the bottom, y over 12. So if we choose any of these two, we're going to start at the bottom as well. So maybe we can say 2 over 1. Let's take that one, 2 over 1. Okay. Remember, the ratio, the division, y over 12 is equal to 2 over 1. That is the same ratio, is constant. Then we can use the LCD. LCD is what? Is 12. So what do? We multiply by 12 both sides. That cancels. Y is equal to 2 times 12, as you had said, it is 24. Okay, and remember, if we're talking about distance and time, remember in this situation, this is basically what? X there, distance. So that would mean we have kilometers, and then the time, y, that's hours. Okay. Milan is one. If you want to check out geometry and angles, as I said in the YouTube channel, I once did a live, whether it's grade 8 or 9. Grade 8, there's a playlist there. You can watch it till your heart's content. You don't even have to wait for me, all right? Because unfortunately now I'm doing paper 1. But in the YouTube channel I've uploaded a 4-hour long, I did a session with grade 8 yesterday on geometry. It's that. After this session, when I'm done, I'm going to answer this question paper, grade 9 mathematics paper 2, after I'm done with this session for paper 1, grade 9. So yeah, okay, so hopefully that is clear, guys. For direct proportion, we understand that one too. Okay, next question. Okay, now we are here, 4.1, number patterns. 15, 22, 29. Hi guys, this one should be fine. Write down the next 2 terms in the pattern. Help me out. What are the next 2 terms in the pattern? This is 2023, sorry. 2023. This is the paper 1, grade 9, November 2023, paper 1. Yeah. Write down the next 2 terms in the pattern. 15, 22, 29. Just write down the next 2. So the following 2 terms, you first look at the pattern, look at what is happening with that pattern. 15 to 22. How did you get from 15 to 22, and how did you get from 22 to 29? So I'm sure you can see there in 4.1 that there's a constant difference of 7. 15 to 22, you add 7 there. Okay, 15 to 22 to 29. So it's simple here, 7. So 22 minus 15 gives us 7. 29 minus 22 is 7. So that means to get the next term, 29 plus 7, I'm going to get 36. And then 36 plus 7, I'm going to get 43. So what are the next 2 terms? 36 and 43. That's pretty straightforward. So what type of sequence is this? This is a linear number pattern. And what did we learn this year about linear number pattern? Linear number patterns have a general term of Tn is equal to Bn plus C, or you could say D, all right? This B stands for our constant difference, right? And we usually use this formula to get the constant difference, T2 minus T1, or we could compare T3 minus T2. In other words, the difference between the consecutive terms, okay, will always give us the same value. Okay, that's what we refer to as the constant difference. So if we want this B value, we usually use the formula T2 minus T1 and compare it with T3 minus T2. If we get the same value, it means that the difference is constant. So for instance here, T2 minus T1 gives us 7. T3 minus T2 gives us 7. So this means this is definitely a linear number pattern. What is a linear number pattern? It is a sequence whose first difference is constant. Okay, that is a linear sequence. It is a sequence whose first difference is constant. So for instance, this sequence has a first difference that is constant. What does constant mean? It has the same first difference. The word constant means the same first difference for all consecutive terms. So it's very easy to find the next 2 terms from a sequence that has a first difference that is constant, because you constantly are adding 7 to the next and to the next term to get the next term. Okay, that's 1. 2, determine a rule to describe the general term. So they want me to find this rule for this particular sequence, 15, 22, 29, 36, and 43. So what I'm going to do is I'm first going to get the value of b by saying term 2 minus term 1 and then confirming it with term 3 minus term 2. Very easy, guys. That term 2 minus term 1 is 7 and it's the same as term 3 minus term 2. So I'm very confident that that 22 minus 15 is equal to 7 is obviously my constant difference, no doubt. All I need now is the value of c, and I see the answer there. Very good, very good. Tn is equal to 7n plus 8. I just want to go over the method so that all learners can be on board as to how we get the c value. How do we get c? Now guys, personally I love getting c in the following way. So once I have my value of b, which is the constant difference, I substitute in the place of b 7. All right, I substitute in the place of b, that's 7. I hope that makes sense. So there it is, isn't it? Then I want c. So I'm going to check any term and substitute its position. Okay. I'm going to show you how to find c in two ways, right? You can take any of these terms here. So if I decide to take this term, which is 29, what position does 29 occupy? Okay, this is term 1, this is term 2, so 29 occupies position 3. So if you decide to substitute in the place of Tn 29, then you are going to accompany the substitution of 29 with the position that 29 occupies, which is the third position. So n is 3. Then you are going to now solve for c. So 29 is equal to 21 plus c. You take the 21 over, transpose it, it becomes negative 21, and then 29 minus 21 gives us what? 8. Therefore c is equal to 8. So if we write down now the formula of Tn, it is 7n plus what? Plus 8. That is Tn. So this is one way of finding c. Or you can always find c. If you have term 1, you can subtract from term 1 the value of the constant difference. If you have term 1, you can subtract the value of the constant difference from term 1 to get c. So you can say c is equal to, what is term 1? Term 1 is 15. What is b, the constant difference? It is 7. What's 15 minus 7? It is 8. So this is another way of getting the c value, not the constant difference, sorry, but the c value, which is basically this constant term, right? So therefore you can then conclude that Tn is equal to 7n plus 8. So I want to suggest that any of these methods is fine to getting the value of c, right? You substitute the term and its position, you can always solve for c. Whatever term, you can substitute the fourth term for all I care. 36 here, you substitute 4. If you substitute 15, you substitute 15 here, then its position is 1. If you substitute 22, you substitute 22, its position is 2. Then you solve for c, and you get the nth term, which is 7n plus 8. Okay. Guys, in as much as you are following me here, I really thank you. Please do go and subscribe to my YouTube channel. The link is in my bio. You just copy the link in my YouTube. You copy the link from my bio. Yeah, don't mind the the WhatsApp channel link. Just copy the YouTube channel link. Copy it and paste it on your Google search engine. Then after you copy the link and you paste it on your Google search engine, you press search, then it should lead you to my YouTube channel. There, guys, I have playlists. You can go to my playlist tab. If you are in grade 8, grade 9, you can go there, subscribe. You can watch all the live videos, the live sessions that I've done on TikTok. Whenever you may have seen me here and you have missed something, you can always go and watch. I'm sorry, guys, the quality of the videos are not the best because I upload the videos as they are, and I know sometimes people complain about quality and all of that stuff. The time is coming when my quality will be quality, but for now, all right, humble beginnings. We'll get there, guys. We'll get there. I know some of you picture me, doing things better. I will, don't worry. Just be patient with me. Be patient with my time and the process, and we'll get there eventually, right? To the glory of God, of course. So now that there, we get that very nicely. It's easy math. Let's move on to the next question. Wow, that was a blow. Study the following geometric pattern. Look at it, guys. We got 1 block, followed by 4 blocks, followed by 9 blocks. You can see the blocks there. 1 block in figure 1, 4 blocks in figure 4, figure 2, and then we've got 9 blocks in figure 3. So they are saying now draw figure 4. So you must notice something about the pattern, guys, because in order to draw the figure, right, look at the bottom for each figure. So for the first figure you have 1 at the bottom. For the second figure you have 3 at the bottom. For the third figure you have how many? 5. So there is a 1 to 3 to 5. So there's like an odd number development in the bottom of your blocks. So 1, 3 to 5. If you look at the next row of your blocks, you have 0, nothing at the top for the first figure, 1 at the top of the second figure, then 3 for the third figure. Okay. So if you are going to draw your fourth figure, what you're going to have is you are going to have 7 blocks that are going to lie at the bottom. All right, yeah, 7 of them, guys. 7 blocks. So I hope you understand what I mean. 7, guys. 7. Yeah, because this becomes important when you are drawing your thing. So that's very important because 4.2.1 is saying draw figure 4. Okay, draw figure 4. So hopefully we all see what we need to draw there and how it will be different. Use your ruler. You make sure everything is pashash, right? I believe that you guys can do that very nicely, no problem. Okay. So I'm not going to really draw that one, but I'm sure you guys understand what you would have drawn in that figure. Okay, as I said, figure 4. I think that's one of the things that you guys are very good at. I've noticed even with my students, even the students that are not so good at maths, but when it comes to drawing the figures, they're so good at it. Okay, yeah, so figure 4 would basically have at the bottom there, you are going to have 7 blocks at the bottom. All right, yeah, and then 5 in the second row, right? Then you have 3, then 1, and that's it. Okay, yeah, so basically that's it. That's how you would basically have it, and in total you will find you have 16 of those squares in figure 4. Okay, then let's look at 4.2.2 in that table. We have figure n, which is 1, 2, 3, 4, 5, 6 in that figure n row. Then number of squares in T: 1, 4, 9, 16. What is A and B, guys? What is A and B? What is A and B? What do we have there, guys? A will be and B will be. I'm sure you can see what's happening there. Amila or Amila. Very good. A is going to be 25. And what about B? A is definitely going to be 25. Okay. Because if you're paying very good attention, you're going to notice that For every figure n, what's happening? Figure 1, to get 1, what are they doing every time? From 2, what are they doing to 2 to get the number of squares? What are they doing to 3? What are they doing to 4? What are they doing to 5? And then B, Amila, you are correct, it is 36. What are they doing to 6 to get B? Okay, so in every situation there, you are correct. A is 25, guys. B is 36, all right? Yeah. Very good, Amila. It's square numbers. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So that's why we have 25 there, and then 6 squared. That's why we have 36. So they are squaring every natural number, so that they get the numbers that you see for your pattern. All right, so definitely then write down the rule to show the relationship between n and t. So that means t is equal to n squared. That's what we know is the relationship. T, which is the number of squares, is found by taking the position, all right, the position, and squaring it. Okay, I hope that makes sense. The position and then squaring it. Okay, so that's why you say t is equal to n squared. That would be the answer there. Right, let's go to 4.3, guys. Study the table below. We have length of call in minutes, 0, 1, 2, 3, 4, 5, and B. Then we have cost, which is rands and cents, 0 rand, 150, 350, 450. A, which we don't know, 7 rand 50 and 9 rand. So they are saying, is the data in the table above direct or inverse proportion? You guys should be able to answer this one. If you look at the length of call in minutes, what's happening with the length of call in minutes? Is this an increasing length of call in minutes? Definitely yes. Look at the cost in rands and cents. For every minute, what's happening to the amount that you are having to spend in rands and cents? It is increasing. So an increase in the length of calls leads to an increase in the amount of money that is being spent. So is the data in the table above direct or inverse? It's definitely going to be direct. I'm sure you can see that. It's direct. Then they're asking us in 4.3.2 to find the missing values of A and B. Now, for most of you, you have noticed that there is a constant difference in the cost in rands and cents. You know, there's 0 rand to 150, 150 to 3 rand, 3 rand to 450. So you guys have noticed a constant difference in the cost in rands and cents for every minute that you're having to actually make a phone call. Then look at number 4. They want us to find the value of A. So what do we do there? All right. So there's 2 things we could do to find the missing value of A and B. We could either use our understanding of direct proportion, the fact that we had said earlier on that for direct proportion, we know that the ratio is what? Is constant. All right. So we could, if we wanted to, find the value of A by saying A over, because remember, this would be ratio is constant. A over what? A over 4 is equal to 4 rand 50 over what? 4 rand 50 over 3. Okay, we could do this way because we know that for direct proportion, the ratios are constant. But we need to just make sure that our unknown is in the denominator. So we start at the bottom to the top. A is over 4. Then 4 rand 50, because we start at the bottom, is over 3. Then we can cross multiply. We multiply both sides by what? By 4. That cancels the A. A is equal to 4 rand 50 times 4 divided by 3. We use our calculator. You guys should be able to get that amount. Some of you can do that that way, get the value of A in that way, what will you get? Of course, you're going to get 6 rand, right? 6 rand is going to pop whether you like it or not. So we are going to get that 6 rand, right? No doubt. Okay, which is the same 6 rand value you would have gotten had you added 1.50 rand to the value of the previous amount, which is 4.50 rand, because you notice that there's a constant difference. You could have done it the constant difference way, or you apply the direct proportion understanding that you have, because you know that the ratios are constant for direct proportion. Okay, no problem. You can always go watch the uploaded when you come back from church, no problem. Then what about B? Same thing with B. Okay, take anyone. We're gonna say B over 9 rand. Okay, and then we can say it's equal. We can take any. Okay, let's say we take 2 over 3 rand. Okay, and then what do? We cross multiply. So B over 900, starting at the top to the bottom. Take another one, start at the top to the bottom. Then we do what? We multiply both sides by 9 rand. Remember, I want to get rid of that denominator. So we just multiply by 9 rand. So that cancels. What we do on the left, we do where? On the right. Okay. So B is equal to, what is the value, guys? What is the value? What are we expecting anyways from the value? It should line up at the end of the day. What are we expecting there? Okay. Surely 2 times 9 is 18. 18 divided by 3 is 6. We're expecting that, right? Okay. Yeah. So, yeah. 6 what? 6 minutes. Yeah, so whether you decide to add the constant value, I'm just applying my understanding of direct and indirect proportion. Okay, hopefully that makes sense. Okay, so that is it. That finishes that question 4.3. Let's move on to the next one. Okay, next question. Complete the table using the given equation. Plot the points on the provided Cartesian plane. Join the points to form a straight line. So now we are entering into the world of linear graphs. Graphs are so important. Join the points to form a straight line. Equation is equal to negative 2x plus 1. So all we need to do is first complete the table. So in the first row of that table, we have the x values, negative 2, negative 1, 0, 1, and 2. Then in the bottom row, we have the y values, 5, 3. Then we have those open spaces, which we need to fill in, right? So those open spaces that need to be filled in will be found how? We are going to take the equation y is equal to negative 2x plus 1. And what are we going to do to it, guys? We are going to substitute 0 so that we can get the y value. So in brackets, we substitute the 0. That means 0 plus 1 gives us 1. So y is equal to 1. So in that table, we'll fill in there where the y value is under 0. We will fill in there the 1. Very important. Then we do the same thing with y is equal to 1. X is equal to 1. We go and substitute in that same equation. Y is equal to negative 2x. We substitute 1 in brackets. Then we get negative 2. Because negative 2 times 1 gives us, negative 2 times 1 gives us negative 2 plus 1. Yes, very good. See. We get y, which is equal to negative 1, right? Then lastly, 2. We go to the same equation. We substitute in the place of x, what? 2 in brackets. Okay, we use that same equation. Then we multiply. Negative 2 times 2 gives us negative 4 plus 1. What's negative 4 plus 1? That gives us negative 3. I take it that by your silence you guys understand, and that's why no one is asking anything. You guys are good, and you are good, right? So y is equal to what? -3. I hope that makes sense, and I hope you understand that one, yeah? So that's how we fill in the table. Then they are saying, plot the points on the provided Cartesian plane. Guys, I know that I don't have the exact graph there, but what I'm going to do is I'm actually going to do this because I want to see if we all understand how we identify the points from the Cartesian plane, because I am so sad to see that many learners don't know how to identify points on the Cartesian plane, and it's sad for me to see that. I don't understand why learners can't do that. Okay, so the Cartesian plane that you have goes up to 6, right? And that Cartesian plane, it is actually providing all the values up until 6 and -6. Okay. Sorry guys, I'm gonna minimize this to a minimum. Please guys, listen to me and listen to me well. So firstly, I just want to write down there was a -2 and a -1. The -1 was accompanied by 3. The -2 was accompanied by 5. This is x at the top, this is y at the bottom. That's my table. Now I want you guys to see how. Okay, again, I'm gonna minimize this, sorry. Okay, just chill guys. Our first point, we have the x, which is -2, and y, which is +5. Guys, this is x, this is y. Where is -2 for x? Where is -2 for x? Guys, this is the x-axis, this is the y-axis. -2 for x, here it is. But what you need to understand as a learner who's doing maths is that -2 is everywhere on this vertical line, because the value x is -2 represents every x value on this vertical line. Then y, which is +5, where is that? Y, which is +5, is everywhere on this vertical line, right? So in other words, this here guys represents this -2 and 5. So x, which is -2 guys, is here. Okay, y, which is +5, is here. Okay, where do they meet? Right, this is like your mom one day decided to go to a place, maybe it was a restaurant, but it was still within the -2 boundaries, you see. Maybe they decided to go to your school or to a school somewhere. Then your dad met your mother. Yeah, so this is like your dad, this is like your mother. -2 for x is like your mother. This is -2 everywhere on this vertical line. This y, which is +5, it's everywhere on this horizontal line. It's like your father. Okay, they met here. That's the point of meeting -2 and 5. They met there. So you mark that point there, please guys, man, because this is sad to see learners not get the labeling of points. I don't understand why. Then the next point, x is -1, y is 3. Where is x that is -1? It's everywhere on this line, vertical line, -1, here. Okay, y that is +3, everywhere here. Where are we meeting? There, right? So that is -1 and 3. X -1, y +3, there. 0 and 1. X that is 0. Guys, x that is 0 is everywhere on the y-axis. On the y-axis, x is equal to 0. On the y-axis, x is equal to 0. then y that is positive 1, that's here. So we are meeting there, guys. That's where they are meeting. Are you with me? Please, please, please. X that is positive 1 is here, everywhere on this vertical line where x is 1 passes. Y that is negative 1, that's here. Where are we meeting? Here. See, in the part of 0, you need to understand this. When we say x is equal to 0, we mean the y-axis. X is equal to 0 means the y-axis. This is the line x is equal to 0. The y-axis is the line x is equal to 0. So the minute you say x is 0, you mean the y-axis. So it's everywhere on this line. All right? Y is equal to 1, on the other hand, is everywhere on this horizontal line that passes through 1. Where do the two meet? Where are we meeting? We are meeting here. Okay. So if you don't understand the part of 0, then I don't know why you don't, because like I said, x is equal to 0 is the y-axis. Now you need to explain, you need to say to me in the comment section, I don't understand still, or I understand, because it is sad for me to see learners not being able to identify the points. X is 0 is the y-axis. It means everywhere on this vertical line. Anywhere on this vertical line is x is equal to 0, anywhere. But the minute you say with y that is 1, then you are being specific that on this horizontal line, that means everywhere where y is equal to 1. Where are the two meeting? They met here together. Okay. See, I am waiting for you to say that you are fine. Okay. So we started with x, the x value. What is x is equal to 0? X is equal to 0 is the y-axis. Okay, it's the y-axis. That's x is equal to 0. Everywhere on this vertical line is x is equal to 0. Then secondly, y is 1. Y is 1 at the same time. Where is y is equal to 1? It's everywhere on this horizontal line. Where do the two meet? They meet there. Dimples, it's not x. X is not the y-axis. You see, this thing, now you guys are confusing it. I am saying to you, the line x, when you say x is equal to 0, you mean the y-axis. Everywhere on the y-axis, this is the line x is equal to 0. The line x is equal to 0 is defined by the vertical line, which is the y-axis, which passes through 0. This is the line x is equal to 0. Just like if I say x is equal to negative 1, x is equal to negative 1 is everywhere on this vertical line. If I say x is equal to negative 2, x is equal to negative 2 is everywhere on this vertical line that passes through negative 2. If I say x is equal to negative 3, x is equal to negative 3 is everywhere on this vertical line that passes through negative 3. X is equal to negative 4, x is equal to negative 4 is everywhere on this vertical line that passes through negative 4. Okay, you need to understand that all my x values are everywhere on the vertical line. If I say x is equal to 2, guys, then it's everywhere on this vertical line that passes through 2. Guys, this is not x is equal to 2 alone. X is equal to 2 is everywhere on the vertical line passing through 2. Okay. No, you don't. You don't have to plot the point. All right, you don't have to write that negative 2 and 5 for every point. Okay. Especially when your graph paper is very clear. You see, so for instance, if you look at this graph paper, okay, you can see that that one is very clear. It's like it's going up by 0.5. So it's like 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6. So always check. If they give you graph paper, just check what is the development of your graph. All right? Okay. But I'm doing this so that you guys can just not make this confusion, guys. When you say x is equal to 0, you mean this entire vertical line which is x is equal to 0. This is x is equal to 0. Then if you say y is equal to 1, this entire horizontal line passing through 1 is the line y is equal to 1. Where do the two meet? Because the minute you say the point 0 and 1, you are saying where are these two meeting? Okay, so x is equal to 0, as I said, is the entire y-axis. This is the line. The y-axis represents the line x is equal to 0. Then if you say y is equal to 1, the entire horizontal line passing through this one is y is equal to 1. Then you want the point. Where do they meet? They meet there. That's the point. If you guys still don't understand, then I am sorry. I am sorry. I don't know what more I can say to you guys. Where do they meet? You see, remember with the negative 2 and 5, we said where is x is equal to negative 2? X is equal to negative 2 is everywhere on this vertical line. X is equal to negative 2 is everywhere on this vertical line. Then y is equal to 5. Guys, the y value is a horizontal line. Y is equal to 5. It's everywhere on this horizontal line that passes through 5. But where is the point where they meet? Negative 2, 5. We meet there. Again, negative 1 for x, positive 3 for y. Where is x is equal to negative 1? X is equal to negative 1 is everywhere on this vertical line. Where is y is equal to 3? It's everywhere on this horizontal line. Where are we meeting? We are meeting there. X is equal to 0 is the y-axis. X is equal to 0 is everywhere on this vertical line. What about y is equal to 1? Y is equal to 1 is everywhere on this horizontal line passing through 1. Where do they meet? There. Yes, guys, the negative numbers are this side of this plane, and then the positive numbers are this side. Okay, we call this the first quadrant. This square quadrant, we call it the first quadrant. This here is the second quadrant, this here is the third quadrant, and then this here is the fourth quadrant. So these are quadrants. Here y is positive, x is negative. In this quadrant, x is positive, negative, y is negative. In this quadrant, x is positive, y is negative. And then in this quadrant, x is positive, whereas y is positive. Okay, so it's very important to note those things, because once you know those things, then you can be able to identify your points. Then let's go. What is the line? It is the function. It is actually the representation of the function. I'm going to be done now. Let's just identify the points in value one step at a time, okay? So let's first know how to identify the points, because when we know how to identify the points, we are good. So x is 1 here, ne? X is 1 means everywhere on this vertical line, right? And then y is negative 1, everywhere on this horizontal line passing through. Then where's the point? It is here. Lastly, 2 and negative 3. X value is 2. Where is x is equal to 2? Everywhere on this vertical line that passes through 2. Very important. Y is negative 3. Everywhere on this horizontal line. Where are we meeting? Here. Then, my good friends, you take your beautiful ruler. Okay, I am going to freestyle it because I am holding my phone with the other hand, but you will take your beautiful ruler and you will take and draw. Okay, you will draw those points and connect them. Make sense? You are going to connect those points, and because your Cartesian plane will be nice and measured properly, you are going to have a straight line that is not like this, because I have not measured, right? Okay, you are going to have a nice straight line that basically is like this. Now notice the equation. The equation was y is equal to negative 2x plus 1. This here, this straight line you will draw using your ruler. This is what you refer to as, maybe guys, let's just do it with the, you obviously draw this with a pencil. So please do use your, you can definitely draw in the order, mark the ordered pairs, okay? I think let's just use that, say that as a standard rule. Okay, so that will be 2 and negative 3. This point will be 1 and negative 1. that point will be 0 and 1, that point will be negative 1 and 3, and then that point will be negative 2 and 5. Please guys, with a ruler, I'm sorry for my untidiness here, but you guys understand the point. All right, please use the ruler and draw nicely. Okay, remember we were given this equation. What we are seeing here is that in the standard form, the gradient is actually equal to negative 2. That means the gradient is less than 0. We were expecting, when we draw, to have a line that is decreasing, right? So look at the line, it is decreasing. It should be like that. So if you have the equation and the gradient is negative, when the gradient, guys, is negative, you are expecting a decreasing line. Because if the gradient was positive, you'd be expecting an increasing line. All right, so please guys, you should see by that drawing that, oh, the gradient is negative. It makes sense. You see, I have the actual function drawn properly. And please guys, please don't mind me having drawn like this quickly as I have, because remember, if this drawing was done on this Cartesian plane from this in this question paper, then of course there wouldn't have been flaws in drawing my straight line. Plus, if my other hand was free so that I can draw, I would have drawn properly, right? And it would have been a nice straight line. You mark the points, you label, okay? You mark the points, please mark them, all the individual points, mark them, 1, negative 1, 2 and negative 3, negative 1, you know, and so forth. And then you label y is equal to negative 2x plus 1. This is the function, the equation of the function, the straight line. Okay, let's move on to the next questions, guys. The next question says, determine the equations of each of the following graphs. We want to determine the equation. So we need to know how to sketch and we need to know how to determine the equation. So this one here, 5.2.1. I'm sorry, you can see very clearly there. I'm sorry, guys, it's a bit whatever. But our interest there will be to identify the points, all right? So from what we can see in the sketch, right, I'm sorry guys that you can't see it very well, but I'm just gonna draw a rough sketch so that you guys can see what I see there with my eye. That's 2 and that's negative 4. So that's what you see in your sketch, the 2 and the negative 4, right? Once you have points on your Cartesian plane, then it's easy to find the equation of the straight line, right? So for this one, for instance, we know that this is the y-intercept, okay? This is the y, where the graph cuts the y-axis, we call that the y-intercept. You remember the standard form of a straight line equation is y is equal to mx plus c. So here we have this. This value that you have there is the value of c. Okay, you will get the rest of the explanation in the YouTube channel, guys. Please, all of you who are leaving, having to go to church and all of those things, you will get the rest of the explanation. Please hop onto my YouTube channel when you come back from church. I will actually save this video, I will upload it there. You can go and watch it at your own time. I'll label it as grade 9 maths paper 1, and I will actually upload it there. So if you have subscribed to my YouTube channel, you'll definitely get it there when you come back from church. Okay, so this is the y-intercept. This c value is this 2 here. So you can say, okay, please guys, this the name of the YouTube channel, please, the link is in my bio. It's called Maths is a Game as well. All right, Maths is a Game, but the link is in my bio. Just go to my bio, the link is there. You copy and paste, copy the link, paste it onto the Google search engine, and then you should search it from there. Okay, I've also done grade 10 paper 1 in the past. You can go to my YouTube channel. I've done grade 10 recently. There was a kid that I did a live session with the grade 10 paper 1, and I've uploaded the paper there, at least what I did there. You can check out there. There's functions, there's everything. Go check it out, man. Okay, so 2 here, all right, and even grade 8 maths paper 1. Go check it out in the YouTube channel, guys. There's playlists that are there for you guys. Factorization I've done. You can go check it out. All these people who are in other grades, you are interfering with this lesson now. So please go check out my YouTube channel. The link is in my bio. Copy and paste. Copy the link. Copy it. Paste it onto your Google search engine and go and check it out there. Okay. Please, guys. I just want to finish off with this. All right. I think grade 9 factorization type questions are coming up after question 5. So if you're in grade 9 and you want factorization, just bear with me. Let me finish how to find the equation of a straight line. So here, 2, guys, is the y-intercept. So C, I can say y is equal to mx plus 2. All right. By the way, if I was to write down the coordinates for here, these coordinates are 0 and 2. Right? Okay, remember, this is a different question, guys. It's a different question. Find the equation. We are finding the equation from 5.2.1. Okay, different question from what we had just completed and finished not so long ago in the other question. So yes, there we have it. Okay, yeah. So 0 and 2 is the coordinates of the y-intercept, but we know that the C value for my equation, where x is 0, this C value or this y value is the y-intercept. So I can say y is equal to mx plus 2, and I have part of my equation so far. Now I need my gradient. That's what I'm short of. So to find the gradient, I can simply substitute the other point. What is the other point? This -4, it is on the x-axis. I know that my coordinates there, x is -4, but y is 0. On the x-axis, my y value is always equal to 0. Okay, so I can substitute -4 and 0, and then in the place of y, remember this is x, this is y. In the place of y, I'm going to substitute 0. In the place of x, -4 plus 2. Then I'm going to transpose the 2 over. It becomes plus 2, becomes -2, -2, 0 minus 2 gives us -2. Then we have -2 is equal to -4m. We can now divide what? Both sides by the what? The coefficient of m. What we do on the left, we do on the right. So that leaves us with half. M is equal to half. Therefore, m is equal to half. Now the equation, y is equal to half x plus 2. This is the equation of the straight line. So let's take it up from the top again. For those who are totally lost, remember, I was given a sketch. In the sketch, I have this value here, which is -4. This is called the x-intercept. In other words, this is where the graph cuts the what? The x-axis. This is where, on the x-axis, this is where y is always 0. On the x-axis, guys, y is the one that is 0. So if I want to write down the coordinates of this point, which is on the x-axis, the coordinates of this point are what? X is -4 here, whereas y at the same time is what? Is 0, since the point lies on the x-axis. So we have -4 and 0. These are the coordinates, -4 and what? And 0. Then here, this is the y-intercept. It is called the what? The y-intercept. This is where we let x be equal to 0. So that means our x-coordinate here is 0, whereas y is what? It's 2. So the 2 points that we have here are the x-intercept, which are 0 and 2, and the y-intercept, which is 0 and 2, and the x-intercept, the coordinates, which are -4 and 0. To start off, if I want to find the equation, I need 2 things. I need the gradient and I need my y-intercept. C is what we call the y-intercept. What is the y-intercept? That is where the graph or the straight line cuts the what? The y-axis. Where is it cutting it? Here. What is the value of y here? It is 2. So since the value of y is 2, where the graph cuts the y-axis, it means my c value is 2. So that means in the place of c, I can substitute this y value, which is 2. Why can I do that? Because it is the y-intercept. What does this c represent? It represents the y-intercept. So the y value, or the y-coordinate of the coordinates of the y-intercept, is the c value. So that's why in the place of c, I write positive 2. Because if it is the y-intercept, I can do that. Then my mission now is to find the value of m. So what do? I use the other point and substitute it into the equation that is already there, which is y is equal to mx plus 2. I go and substitute the other point, which is -4 and 0. There, x is -4, y is 0. So in this equation, where y is, I substitute 0. Where x is, I substitute -4. Then I'm going to do what? Solve for who? For m. So when I solve for m times -4 gives me -4m. This positive 2, I'm going to take over to the left-hand side. It is positive 2 at the moment. When I take it over to the left, it becomes -2, because when you transpose or you take a term over, the sign of the term changes. From positive 2, it is now -2. Then I have -4m. I need to solve for this m. This -4 and this m are multiplied together. So I'm going to get rid of this -4, which is multiplied to m, by dividing by the same -4. But what I do on the left, I must do where? On the right. What I do on the right, which is divide by -4, I need to do on the left. So I divide this side as well by what? By the same -4. Negative divided by negative is positive. 2 divided by 4. Now, if you use your calculator, or you know how to simplify fraction, you will know that 2 over 4 can be written as half. So that means my m value, negative divided by negative, is positive. 4 divided by 4 is 1. I'm left with m. m is equal to half. This is my gradient. It is positive. This indicates a straight line that should have been increasing. Is my straight line truly increasing? Yes, it is. Does the gradient value I have make sense in light of this? Yes, it does. So then I can write now my equation. It was missing the gradient, by the way. I had c. So y is equal to half, in the place of m, x plus 2. This is the equation of the straight line that I wanted to find. This is one way of finding the equation of a straight line when you are given the y-intercept and another point. When you are given the y-intercept and another point, when the y-intercept is given, you can substitute the y-intercept there in the place of c, because c is the y-intercept. It is the y-coordinate of the coordinates of the y-intercept. You can substitute it there. Thank you so much, Moonlight. I really appreciate the rose. Then after that, you can then go ahead, guys, after substituting the y-intercept, which is 2. Thank you so much, guys. You can go ahead and do what? Substitute the other point. Once you substitute the y-intercept, guys, you can't go and substitute the very same points to solve for m. No, you must go to the other point. You've exhausted this guy by substituting his y-coordinate. You've exhausted him. He is exhausted. Now you just need to go to the other point, which is -4 and 0, and do what? Substitute the x and the y value of the other point. -4, which is x, you substitute. 0, which is y, you substitute. Then you solve for who? For m. Take the 2 over, becomes negative 2. M times negative 4, negative 4m. Solve for m. Divide by the coefficient of m, which is negative 4. On the right, what you do on the right, you do on the left is, then you divide, you get half. M is half. M is half, and it is a positive gradient. Look at the gradient. Look at the diagram. It is increasing. Is this gradient meaning it's increasing as you see in the diagram? Yes. My gradient makes sense. So therefore, y is equal to half x plus 2. Even my y-intercept makes sense, because when I look at where the graph is cutting the y-axis, it's cutting it at 2. So the fact that c is 2 makes sense. My equation makes sense. My answer makes sense. 100% is coming my way. It makes sense. Okay. Right. If maybe you were someone else maybe would have decided to do the following instead of doing this method. Okay. Someone else could have decided, okay, what are the coordinates of my y-intercept? 0 and 2. Then, what are my coordinates of the x-intercept? Negative 4 and 0. Then they would have decided to say, let me calculate the gradient. Someone else could have decided that. All right, let me first calculate m, the gradient. Then remember, you must look at your first point for your coordinates, which is 0 and 2. Look at your second point, which is negative 4 and 0, and then say, if this is your first point, that means this is my first point for x and my first point for y. Then this is your second point. This is my second point for x. This is my second point for y. Right? Then you go ahead and you use the formula. y2, change of y over change of x, is the gradient formula. y2 means my 0. I've assigned it. The formula already has minus. You write the minus sign. y1 is 2 over x2 is negative 4. The formula has a minus, you write it down. x1 is 0. Then what's 0 minus 2? Negative 2. What's minus 4 minus 0? Negative 4. Then what is the gradient answer? It is negative divided by negative is positive. 2 over 4 gives you a half. Therefore, you say y is equal to, you go to that general standard form equation of your straight line. You write y is equal to mx. Then in the place of m, you write half x plus what? Plus c. Now you need c. You have two approaches that you could either use. You can take any point, substitute it, and solve for c. Okay? You could take any of these points, substitute and solve for c, or because you know that this here is the y-intercept, remember I said the y-coordinate of the y-intercept, where the graph cuts the y-axis, is the c value. So you could simply go ahead and go and substitute that c value, and that is your answer. Y is equal to half x plus 2. This is another way you could have done the very same question, just in a different way, using the gradient formula. Okay? So this is another way you could have used. You see, we're getting the same answer. You see, aren't we? We're getting the same answer. Okay, equation of the straight line. We've got it. All right. Okay, let me go and do the next one, finding the equation. Now, I love this question. Look at this question. This one is a vertical line, all right, but it's cutting through -3, right? So if you were seeing it properly, obviously you'd have to check out the blocks. Okay, this here is a vertical line. See, Another example. Unfortunately, in the question paper, there's not another example. All right. Yeah, it's this example. I mean, it's this one that's in the test. You have to go and look at other test questions and other exam or other examples or other, in your notebooks and your textbooks. Look at others and go and utilize the method and check if you understand the method. I think that's what's important here. The example here, I can re-explain it and re-explain it over and over again. You will get it once you are able to actually do it on your own. Okay, guys, sorry, it's just that you cannot see, right? You guys cannot see this diagram because it's so small, right? But you see, the thing is, this diagram goes up 5.2.2. You can't see the values. I'm sorry about that. But there you have -2. Then it goes up by 0. It goes down by -0.5. So you have -2.5. Then the following value will be -3. Then it will be -3.5. Then the following value will be -4. So I'm simply drawing out for you so that you can see what you would have potentially seen. Okay. Anyways, so this is a vertical line that's cutting through -3. And my question to you, what is the equation of this line? Right. So to explain this a little bit more, remember I said to you guys, why is there a 5? The reason why there is a 5 is because you look at the diagram that's been given to you. Look at the diagram. Okay, I'm sure you guys can see. Look at the diagram. Okay, if you are going to try and check all the x values, right, where those lines are, right, where you can't visibly see. Okay, look at the 2. The 2 is there, the 4 is there, the 6 is there. The question is, in between 0 and 2, what is that thing going by? So you need to first analyze your Cartesian plane and check what's happening there. So from 0 all the way to 2, those lines that are fine that you can't see, what are those lines? They represent your 0.5. So this is 0 to 0.5. So it's going up by halves. In other words, 0 to 0.5, from 0.5 to 1, from 1 to 1.5, and from 1.5 to 2. So that's why I'm saying 0.5. It's going up by 0.5. Okay. Yeah, so you analyze the given Cartesian plane that they give you. If they provide you with a Cartesian plane, you need to analyze that Cartesian plane. So guys, when the gradient is less than 0, you have a decreasing line. When the gradient is greater than 0, you have an increasing line. If the gradient is equal to 0, then guys, you have a horizontal line. If the gradient is undefined, as it can be sometimes, you are going to have a vertical line. Now, the form of a straight line function will always be y is equal to mx plus c for this scenario, and this scenario. But where the gradient is undefined for a vertical line, it's no longer y is equal to, it is x is equal to whatever constant value that the graph passes through. Just like when you have a horizontal line, it is y is equal to whatever constant value of the y-intercept, whatever constant value of the x-intercept. That is basically how you would write the equation of that line. So guys, I am asking you now to tell me what the equation of this vertical line is. You should be able to simply write it without doing any calculations. Look at this vertical line. It's cutting through what? The x value, that is -3. So basically this vertical line everywhere is equal to what? It's -3. So what's the equation of the line? It's x is equal to -3. It's as straightforward as that. X is equal to some constant for a vertical line, whereas y is equal to some constant for a horizontal line. Okay, so it's as straightforward as that. There's no hard work or anything else that needs to be done there. It's just as straightforward and as simple as that for a vertical line. So please guys, gradient less than 0, decreasing line. Gradient greater than 0, increasing line. Gradient equal to 0, horizontal line. and the gradient is undefined, that's a vertical line. For any line that is vertical, x is equal to whatever the x value is that line is basically moving along. This line is moving along the line x is equal to -3. So the equation is x is equal to -3. When the gradient is undefined, the equation of a vertical line is x is equal to whatever constant that we are talking about. Okay, guys, I think I've overspent my time there with those. I hope we are good. I need to move on to what is following. Algebra. Okay, let us wrap up. Algebra is calling us. Simplify and give answers with positive exponents. Simplify and give answers with positive exponents. So here, guys, for exponents, let's not forget the laws. All right, a to the power m times a to the power n. What do we say? When we are multiplying same bases, what do we do to the exponents? We add them. When we are dividing same bases, what do we do to the exponents? We subtract them. When a is raised to the power m raised to the power n, what do we do to the exponents? We multiply them. When a, b, when the product of different bases is inside your bracket and we are raised to a certain exponent, what do we do to each individual exponent with its space? We multiply each individual exponent by the exponent that is outside. So that is basically a continuation of this law. What about when we have division of different bases? Well, we multiply the exponent for each respective base there. Okay. What about if we have addition and there's an exponent on the outside? Can we distribute the exponent by multiplication? Absolutely not. This here we do not ever do if there's an addition and a subtraction sign. This is pure absolute nonsense. We don't do that when there is a addition and subtraction sign between the bases. So for addition and subtraction, no, we don't ever multiply this with that and this with that. For multiplication and division, it can apply, but for addition and subtraction, it's a no. Okay, it's an absolute no. So for addition, nonsense, rubbish. We don't do this. We cannot do this. Multiply, no, wrong. It's only for multiplication of different bases and division of different bases that we distribute the exponent by multiplication to the other exponent for each respective base. We cannot do that with plus and minus. Rubbish. It's absolute nonsense. We don't multiply the exponents when there's a plus and a minus sign separating the bases. Okay, 1, 2, 3, 4, continuation. Very important. That misconception. We don't ever find ourselves in this water. Any base raised to the power 0 is 1. Any base raised to a negative exponent is 1 over that same base raised to a positive exponent. Okay, and I think we were sort of like clear with this. Something to note here is that if you have x over y and it's raised to the power negative n, you can do this. Invert x and y, and then the exponent changes sign from negative to positive. So if you have a negative exponent, you can actually flip around the two fractions. Y becomes x, x becomes y. This negative sign changes to positive. So these are laws and rules that you need to know for exponents, because when you know these laws and rules, do you know what happens? Exponents become easy. But when these laws and rules are unknown, then what happens is that you actually don't do well in exponents, and exponents become a pain and you hate them and it becomes a mess. So let it not become messy, right? Okay, let's come here now. Let's answer. A to the power 2b times a to the power 3 b to the power 4. Here we are just dealing with multiplication, so that means law 1 is going to apply. Okay, remember when we multiply we consider S, N, L. What does S stand for? We multiply the sign, we multiply the number, we multiply the letter. When you see this on TV, please switch off the television screen and go and do some maths. Multiply the sign, multiply the number, multiply the letter. Don't watch in the television screen this, that, and this. You are not going to grow. You are not going to become a better adult. You are just going to become an adult that basically, or an individual that basically is obsessed with certain things that will basically deteriorate or destroy your character. So let's come here. Sign, number, letter. Positive times a positive, that's a positive. That's the sign done. Number, 1 times 1. There's a 1 here that you cannot see and the 1 that's there. 1 times 1 gives us 1. Move on to the letter. A squared times a to the power 3. So law number 1 applies for a squared times a to the power 3. So I'm going to say a squared 2 plus 3. That's the letter A, same base. Law number 1 applied. B to the power 4, same base. B to the power 1 plus 4. Don't forget that 1, it's there, guys. You can't see it, but it's there. 1 plus 4. Final answer, A to the power 5, B to the power 5. That is the answer. All right. Remember, if that 1, you cannot see it, that means you're not going to add the 1 and the 4, and that becomes a problem for your answer. All right. So that is it. Straightforward. 2 marks, without even blinking. Okay. Next. 2x squared times 8xy squared. Y cubed, sorry. Over 4x to the power what? 4y what? Squared. Okay. So I look at the relationship that exists. I have a multiply and a divide relationship. Multiply and divide relationship is so easy because that means law number 1 and 2 can be applied so nicely, not a problem. So we look at the numerator grade lines. Look at the numerator grade lines. We just deal with the numerator. What's 2x squared times 8xy to the power 3? Let's deal with that first. Applying sign, number, letter. So sign, positive times a positive is a positive. Number, 2 times 8, that gives us 16. Letter, x squared and x, that means x to the power what? 2 plus 1, that gives you x to the power 3. Y, is there y? There's no y this side, there's y that side. We just write y to the power 3 over what? 4x to the power 4y squared. So far so good. Our numerator, we are sorted. The multiplication in the numerator was good. We did the m using s and l in the numerator. Let's go now and look at the entire thing. Now we are going to divide and apply still s and l. Sign, number, letter. Guys, these letters, you are now renewing your mind with these letters. No more watching the movies. Now more maths, so that we can get 85% and above. Distinctions galore. So D for distinction. So now we can divide, right? Sign, number, letter. Positive divided by positive is positive. So we know it's going to be a positive answer. We move on to the number. 16 divided by 4. What's 16 divided by 4? Now, of course, guys, 16 divided by 4 gives us 4, right? Then we move on to the letters now. X to the power 3 divided by x to the power 4. X to the power 3 minus 4. We are dividing 3 minus 4. Y to the power 3 over 2. That's 3 minus 2. Final answer, 4x to the power negative 1. Y to the power 1. 3 minus 2 is 1. But that 1, it's there. We can't see it. It's like God. It's like the Holy Spirit. It's there, ever present. But we can't see with our physical eyes. Then the x. 4y. This x, remember the law that said when we have a base raised to a negative exponent, the base changes position. From the numerator, it goes to the denominator. If it was in the denominator, it had a negative exponent, it would change position. It would go to the numerator. But since it has a negative exponent, it's in the numerator, it goes to the denominator, the sign changes. What happens to x? X goes to the denominator. The exponent changes sign, it's positive, but it's there, we cannot see it. So the final answer is 4y over x. Simple, straightforward, to the point, no problem. You see that? That law that we applied, this law that says when a base is raised to a negative exponent, the base moves to the denominator. The exponent sign changes from negative to positive. Same thing. This base was in the numerator. It moved to the denominator. Its exponent was negative. Now it is positive. This is x to the power positive 1. It was x to the power negative 1. Where was it? In the numerator. Now it is in the denominator. Its exponent is negative here, but its exponent now is positive. That 1 is still there. It's just not visible. Okay. Okay. We good? How low can you go? Now those are free marks, guys. Freebies. You know free marks? Freebies, these ones. Freebies for days. Next. Thank you, Nkule. I really appreciate the rose. You are so rosy. Okay, let's move on to the next one. 6.1.3. The cube root of 216x to the power 3 minus 16x. Okay. 216 and x to the power 3 are multiplied together. They have a relationship. They are multiplied together. So remember, there was this law that I said, if you have a times b, when the relationship is multiplied, you can split the root for both bases. You can also do this if the relationship is divide. You can split the roots. But I said with addition and subtraction between bases, we can't split the roots. We can't. So here, we can split them because 216 and x are multiplied. What's the cube root of 216? You can grab your calculator. Just tell me what's the cube root of 216. You write the answer. You just write the answer, guys. The cube root of 216. Just take your calculator. Bam! You write the answer. Okay. I'm waiting for people to tell me what the cube root of 16 is. Okay. Then, when you are saying the cube root of x to the power 3, you express this in exponential form. Guys, remember, x to the power m to the nth root is actually equal to x to the power m over n. This is basically how you write a root into exponential form. This becomes your numerator. The root becomes your denominator. So here we have the cube root. This is 3. This becomes the numerator. That 3 becomes the denominator. All right, I hope that makes sense. Minus 16x. So this here is 6. What is 3 divided by 3? It is 1. So we have 6x minus 16x. What are these, guys? Aren't these like terms? Aren't these like terms? They are. What is 6x minus 16x? That gives us negative 10x. Okay, negative 10x. You guys would have to send me like a galaxy, like big galaxy, in order for me to do grade 11 paper 2. And I don't think you have the capacity to do such. So unfortunately then, yeah. Guys, I don't really have that time to do the others. I only have the morning time to really do live sessions, and I'm doing dedicating this time to them. But Manaka, you can go to Kevin Maths and Science. I believe Kevin Maths and Science did a Maths paper 2 full paper on his YouTube channel. You can actually go and watch that full grade 11 Maths paper 2 that he did, and I'm sure you'll gain a lot. He did a past paper, I think. Let's move on, guys. My grade 6.2. Simplify. I have maths paper. You can go in. I wanted you to do it. Manaka, you're funny. Grade 10, you can actually check out my YouTube channel. There was a live session I did with grade 10 paper 1. I did numbers, I did functions, so you check it out. I did, but I didn't do all of it. We'll see later on this evening if I can't fit in some time for you guys. Grade 11s and grade 10s, we'll see. It's just that I don't really have time. Simplify the following expression: x minus 10 into x plus 4. Guys, this one, very nice. We are applying once again the beloved distributive law. All right, FOIL. You know most FOIL. So we DLing using SNL. We always SNL, guys. Distributive law, okay, FOIL. Okay, yeah, this multiplied by that. Okay, when we multiply this with that, what do? We say the positive times the positive, sign, number, 1 times 1 is 1, letter, x times x, we know is x to the power 2. Done. Distributive law again using SNL. Positive times the positive. 1 times 4 is 4. X next door, multiplied, we combine the x. Distributive law. Negative times a positive, negative. 10 times 1, 10. X next door. Then last distributive law. Negative times a positive, negative. 10 times 4, 40. No letters. Then, like terms, guys. X squared. What's 4x minus 10x? Negative 6x minus 40. Finished. Finito. Okay, that one is very nice and straightforward, guys. That's a meal. It's like dessert. This is grade 9 maths, definitely. Paper 1. This is a meal. Nice meal, this one. Beautiful meal. Like easy marks. It's coming so nice and easy. Look at this next question. 6.2.2. That one is saying 2x minus 4, the whole thing squared. Let us be careful here, guys, that when we do this one, we make sure that we don't make that mistake. Remember, I said to you earlier on that we can't square the first term and then square the last term and think that's the answer. Remember, I said to you that this is nonsense to take that exponent, apply it here, take that exponent, multiply it there, and think that's the answer. It's absolute rubbish. Nonsense. Here, what is this saying to us? It's saying to you, open what? 2 of these. That's what this is saying. Open what? 2 of these. There they are, 2 of these. It's 2x minus 4 and another 2x minus 4. Please, guys, open what? 2 of what? Of these. There they are. Now I can apply same thing. DL, FOIL using SNL. Guys, you will never look at SNL the same way. You will never. Switch off that television screen. Go and do some math. Go and FOIL. Go and SNL here. Sign, number, letter. Okay. So we are here now, right? So we've opened. Now we are foiling, and we are doing this DL, SNLing it. Positive times a positive, key positive. Number 2 times 2, key 4. X times x, key x squared. Answer, key 4x squared. Right? DL. So we distribute this guy here first, and then we distribute the same guy there. Finished. Take this guy, distribute him here. Take the same guy, distribute him there. You see, we are just distributing here. 2x times 4. Positive times a negative, key negative. 2 times 4, key 8. Key x, x next door. Inner. Negative times a positive. Negative times a positive, key negative. 4 times 2, key 8. X next door. Last. Negative times a negative. You want to see the answer for 2.1.6.1.2. Here it is. So Dimbo is saying start over. Start over for what? What are you talking about? 6.1.2. Here's the answer for 6.1.2. What is this? These people are coloring me. There it is. Sky, you are a level 21 gifter. Yo. It's like you are the one that are supposed to be pouring down galaxies here. You are the one that's supposed to be pouring down galaxies. You. Level 21. That means you spend time. You see, that's the funny thing about people that are gifters. Gifters will watch entertainers on screen and give them all these gifts. Like, I see you guys do that, and I'm like, hey, these people. But someone who's doing maths on a live, I am telling you, it's quiet. It's like people are just like, nah, dude, just do your thing. We'll see you when we see you. Funny people, you. Very funny people. Okay, so anyways, 2x minus 4, the whole thing squared, guys. 2x minus 4. Where's Guy? We're not done. 2x minus 4, the whole thing squared. Remember, guys, what did I say? 2x minus 4, the whole thing squared. What does that mean? Open what? 2 brackets of 2x minus 4. We are not done. I just want to re-explain because Dimpo is crying there in the comment section saying, why can't I start over? I can't start over from the beginning. Dimpo will have to subscribe to my YouTube channel and go and watch. See. Yeah. So 2x minus 4, the whole thing squared, right? You open what? 2 brackets of 2x minus 4. There they are. Then after that, you use distributive law. What is distributive law? This first term, you are going to distribute and multiply with this one. Get the term, and then take the same thing, multiply with the second term. Get the answer. Then after that, you are going to take the second term and do the same thing. Okay, I hope that makes sense. So DL, I said use S and L. What is S? S means sign. You multiply. When you are multiplying, guys, you consider the multiplication of the sign. In other words, what's a positive times a positive? Key positive. Then you move on to the number. What's 2 times 2? Key 4. Then you move on to the L letter. X times X, key X squared. So your first term is sorted. Then you take the same 2x, you multiply with -4. You do the same thing, S and L. What's positive times a negative? Key negative. What's 2 times 4? Key 8. What's X? X is not multiplied to anything, so next door you multiply the X. Then you take now -4 and you do the same thing. You distribute him to 2x and then you distribute him to -4. So what's negative times a positive? Key negative. What's 4 times 2? Key 8. X next door. Then lastly, -4 times -4. Now we're getting the last term. What's negative times a negative? It's scrumptiously positive. Then what's 4 times 4? It is 16. You see? So this S and L helps us to check that everything is intact. The sign, the number, the letter. Not what you see in the movies with S and L, but what you see in maths. So whenever you see this in the movies, switch off, go and do some maths. Okay, please guys, don't watch those movies. Take S and L and come and do maths. Very important. Then we add the like terms. We have like terms most in the middle. So 4x squared. What's -8x minus 8x? -8x minus 8x is -16x plus 16. Okay, guys, if I watch your full YouTube video on grade 9 JC Maths Paper 1 Revision Mara, I'll be good exam. Just something to note, my full GEC sessions on the YouTube channel, there I took my time explaining by parts. For instance, part 1 is question 1 of GEC 2022 to question 10. Those questions that are there, of course, are paper 1. I think from question 1 up until a certain question, it's paper 1. But GEC 2022 was both paper 1 and paper 2. So I believe those who are writing on the 13th of November, you are writing only paper 1. So for instance, if you watch the GEC, just the paper 1 part of it, not the geometry, okay, you should be at least having an idea of what to expect in GEC, because the pattern of questions that they ask in GEC 2022, 2023 paper 1 and 2024 paper 1 seems to be relatively the same, because they start with numbers and your number systems, they go on to other topics. So what's important here is to understand the concepts in the topics that are covered in paper 1, right? Then you must practice the papers. Please do watch the YouTube videos, because that playlist for GEC 2022 that I have uploaded there, that has 10 videos. I'm telling you, it will help you. It will remind you of certain things you've forgotten, and it will assist you so that you are okay. All right. What I'm doing here is not a GEC paper. This one is for those learners that are not writing GEC, that are writing a general paper. This is a past paper that was written in another place. So guys, please, my YouTube channel is a good place to go, it's helpful. I've seen some comments that people have written there, and they are very encouraging. All right. Yeah. As from tomorrow morning up until you guys write on Thursday, I'll be doing in the morning at 5 a.m. for the grade 9s. Every morning at 5 a.m. up until 7, I'll be doing GEC. I'll do 2023 and do 2024 past papers, so that you guys can see how to approach the question papers, right? But yes, it's a good thing to check out my 2022. It's really helpful. I started that series in the morning, every morning, those who are joining, and it's very helpful to those people that have watched. Okay, we are done with 5. Okay, whenever, whether you're writing on Friday or you're writing whatever it is, my leader, you continue leading there with that paper, you get full marks. Okay, let's go to 6.2.3. All the best to all of you, my loves. You are all my loves, guys. You are all my loves. I have daughters and sons here in this live. It's so beautiful. 6.2.3, 4x cubed minus 2x squared minus 8x over 2x. Now in grade 8, this question was very nice, because what you did is that you looked at this denominator, and you would, in grade 8, you would split using the denominator. 4x cubed, you can write it over 2x. 2x squared, you can write it over 2x. Negative 8, you can write it over 2x. This is how you did it in grade 8. All right. But now that you are in grade 9, if you want to, you can factorize this numerator. Right. All right. So if you look at the same question, what we can do is we can factorize the numerator. We take out the highest common factor there. We always ask, is there highest common factor? In the numerator, we have 1, 2, 3 terms. What is the highest common factor? And when we take out the highest common factor, guys, we take it out according to still S and L. You see why I'm saying this S and L is so important. You take out the highest common factor sign. You take out the highest common factor number. You take out the highest common factor letter. So if you look at these 3 terms, what is the highest common factor sign? The first term is always the highest common factor sign, so it's positive. Number, what's the highest common factor between 4, 2, and 8? 4, 2, and 8. The highest common factor between 4, 2, and 8. The highest number that goes into 4, 2, and 8 is 2. Thank you. Then letter. Is the highest common factor letter? X is here, X is there. There's no X there, so X is not common. We put it there. Okay? We open the brackets. So that's what's important, guys. Positive 2 is my highest common factor according to sign, number, letter. Remember, when we take out the letter, it must be common for all 3 terms. It must be common for all 3 terms, and it's the common base that has the lowest exponent that I take out. But there's no common x, because this last term doesn't have any x variable. So we don't take out 2. Okay, so it's positive 2. That's the highest common factor. What's left over? 2 times what gives us 4? What's 4 divided by 2? Surely you guys know it's 2. Then the x cubed, that's also left over. For this term, positive times what gives you negative? It's negative. 2 times what gives you 2? That's 1. X squared left over. 2 times what gives you negative 8? That's negative 4, guys, over what? Over 2x. Now, listen to me and listen to me well. This is 2. It's multiplied by this. So if I asked you how many terms are in the numerator, let me just ask you guys, this is very interesting for me. If I asked you guys, in the numerator, meaning the top of this division sign, how many terms are here? Let's see you guys answer in the comment section. How many terms are in the numerator? Let's see you guys make me happy or make me sad. Karabo says 1. Numerical says 3. Alwande Tando says 4. Zuki says 1. After Kakashi says 3. Bigfoot Big Culture says 3. Liwa says 3. You are not making me happy, you guys. Liwa says 3. So and so says 1. Kiki says 3. Ompi says what? Listen to me, guys. Guys, I asked you how many terms are in the numerator. The reality is it does not depend on any interpretation. Someone said it depends on interpretation. No interpretation here. Guys, there's 1 term in the numerator. Why? Brackets for 1 make this 1 term. The relationship, all right, so for instance, if you have 2x plus 4, if I ask you how many terms are here, you can say to me there are 2 terms. I agree with you. I agree fully. There are 2 terms, because what separates terms, guys? It's a plus and a minus sign. So if I say to you how many terms are here, you will say to me, sir, there are 2 terms. I'll be very happy with you, because you are saying something that's 100% correct. But if I say to you 2x plus 4 and then I put brackets around 2x plus 4, then I ask you how many terms are here. There is 1 term. Why? Because a bracket around those terms makes this 1 term. The minute you have brackets around, it makes it 1 term. So it's because there's brackets. Okay. Now, look at this. Brackets bind. I love that. Quintin, I love you, Wena Quintin, you are quintinizing. Look at that. I love that. Brackets bind. There's a unity and a oneness. No, Numpickle, you're not stupid. You just don't know. There's a difference between being stupid and not knowing. When you don't know something, or if you have forgotten something, that doesn't mean you are stupid. It just means you've forgotten, because you can forget, right? The fact that you can forget means you are human, you are alive, you are kicking. You're right. So chill, relax. Don't say things to yourself that basically destroy you. Okay? It's not good for you to say that. All right. So now we understand brackets. You see, if we did not have this misunderstanding in the comment section, you wouldn't be learning anything from me. So I'm happy when you guys forget things, because it gives me an opportunity to what? To teach you something, and to explain something, and to clarify something that you may have had a misconception about. So calm down. Don't say things about yourself that are not true. Okay? Don't be negative. It's not good. All right? So brackets bind. I love that. I love what was said in the comment section. So this is 1 term. But if I said to you how many terms are inside the brackets, then that's a different story. If I say to you how many terms are inside the brackets, then you are going to say there are 2 terms inside the bracket. But if I was to ask you how many terms this is, the whole thing, with the brackets, it's 1 term, guys. Okay? All right. So come back here. We have 2. There's this bracket. How many terms are there? All right. The reality is there is still what? 1 term. Because you see brackets and you see multiply and divide. Okay? Multiplication does not separate terms. Division does not separate terms. These are things that combine. Multiply combines terms. Division combines terms. So when we say how many terms there are here, we say 1. When we say how many terms there are here, we say 1. Okay? Okay, I hope that makes sense, guys. So multiplication and division combine terms, as do brackets, they bind terms. But addition and subtraction, if we look at this just alone without the brackets, how many terms? There are 2 terms. If I ask you here, how many terms? 5x minus 4, there is 2 terms, because addition and subtraction, they separate. Okay, yeah. So here, what is the relationship of 2 with this bracket? It is the relationship of multiply. So when we look at this numerator, we say there is 1 term. 1 term, 1 term. Are we together? Yeah. Says Zuki is eating. Aye, man. Then here, you see? Yeah. So this entire fraction is actually 1 term. So hopefully that makes sense now and we understand that. But listen now, listen to me and listen to me well. So seeing as though this is all 1 term, 1, 2, in the numerator, we have 1 term. We have 1 term. Then it means it is very easy for us to go ahead and divide the 2 that is outside the bracket. Okay, 2 divided by 2. This 2 and this 2, we can cancel, guys. Because cancellation can happen as long as it is not across an addition or subtraction sign. It must not be across an addition or a subtraction sign. Cancellation can happen as long as it is not across an addition or subtraction sign. Okay, guys, I don't know what's happening there. It's blurry. Stop being blurry. Okay, so this 2 and this 2 can cancel. What am I left with then? 2x cubed, right? Minus x squared minus 4 over x. All right. That is simplified. And that's where I would end. Okay? Guys, I hope this makes sense. Very, very important. Okay? Very, very important. So through factorization, I can be able to simplify a given expression. Okay? I can do that because it is feasible and it is possible to do such. Okay? Let's move on now to factorization, because it seems like I can in fact solve for x. Why can't I divide it further? Because dividing it further won't really simplify this any further. All right, all it will do is it will actually just eliminate these, but then for this term it will remain as 4 over x. So this is simplified. This is as simplified as we can get when it comes to this particular question. All right, because those individual terms, let's say we did the individual terms as we would do previously in grade 8, what basically means, what that means is that we need to add those terms, and we would be adding those terms, meaning adding fractions, and the addition of the fractions would lead us here where we have a denominator that is the same, right? And obviously we have unlike terms that we cannot add. So basically we can leave it as this. This is as simplified as the answer can be. This is the simplified answer. Okay, so for grade 9 learners, guys, who've learned factorization, remember I said we are taking out the highest common factor, we cancel. This is the answer that we get left with. We cannot factorize this numerator any further. This x is as simplified as it can get, so we end right here. Okay. Okay, next question. Now we are entering, unlike terms cannot be simplified further. Solve for x. Okay, this is our first problem, and then the other one. What are you, deaf? What's happening? Okay, solve for x, guys. Right, so if we look at this problem, we can clearly see that this is what we call a quadratic equation. Now, with quadratic equations, there is a procedure that we have to sort of align to. This means that it's always good to get the equation in standard form. What is standard form? Standard form means ax squared plus bx is equal to c is equal to 0. Then 2, we factorize. Whatever factorization is feasible, whether that be highest common factor, taking out a common factor, or opening two brackets if it's a trinomial, that means factorization. 3, we apply what we call the zero factor law. Zero factor law. I've done 6.3 now. Okay, done 6.2. Okay, we're doing 6.3.1 and 6.3.2. Okay, that's there at the bottom of the page. Okay, solve for x. So we apply the zero factor law, which simply means that if you have two brackets that are equated to 0, you can take the one bracket equated to 0 or take the other bracket equated to 0. There must be 0 on the other side in order for us to do that. Then lastly, 4, we find our roots. These are our solutions for x. We get our 2x values, and that should basically be the end. This is the procedure that is explained to us that we ought to know when we are solving for a quadratic equation. Make sure the equation is in standard form, factorize, apply the zero factor law, which simply means those two brackets individually, you equate to 0, you solve for x, you get the values, and that's it. It's as simple as that. So if we're looking at this, x squared minus 121 is equal to 0, we can see that this equation is already in what? In standard form. X squared, the x squared term, there's no middle term, so we know that's 0x, but it doesn't have to necessarily be there, and then the constant is negative 121 equal to 0. So this is already in what? In standard form. So what do we need to now do? Factorize, if possible. Okay, so on the left we have x squared minus 121, and this type of factorization that we know we ought to apply here is what we call difference of two squares. So factorization, difference of two squares. But we always ask first, is there highest common factor? We always clarify, is there a highest common factor? If there is, we take it out. If there's not, then we don't, right? But there's no highest, here there's a highest common factor of 1. 1 does not really affect our expression. So what we do is we kind of like know that we have taken out the 1. We cannot see it, but it's there, it's outside. The 1 has been taken out if you think about it. It's just that we don't write it down. Then this is a difference of two squares. That means the first bracket is going to be positive, the second bracket is going to be negative. Why? Because whenever our last term, when we're factorizing, is negative, and our x squared term for our standard form is positive, the negative constant means we are going to have what we call different signs inside the bracket. We are always going to have different signs inside the bracket. Okay, I hope that makes sense, guys. Okay, that's also a method you can use. All right, that's also a method. All right, yeah. And then x squared term, since this is a perfect square, okay, meaning a variable raised to an even exponent, the x squared term, the square root of x squared is x. So we can write x and x here. The square root of 121, since 121 is also a perfect square, it means the square root of 121 is 11. So we can write 11 and 11. That's how we approach the factorization of a difference of two perfect squares. X squared is a perfect square. Why? Because any variable raised to an even number exponent is a perfect square. So you can take the square root of that and basically write that as your values for the first bracket, as your first term. 121 is also a perfect square because it is formed by a multiplication of 11 by itself. All right, so basically the square root of 121 is 11, and that's it. Factorization done. Now we apply the 0, which means there must be a 0 for us to apply the 0 factor law. X plus 11 is equal to 0, or x minus 11 is equal to 0. We call this the 0 factor law. Okay, whenever there's a 0 and a product of factors, we can take each respective expression in the bracket, equate it to 0, and then solve these independently. Now we can say x is equal to what? Take the 11 over, it becomes x is equal to negative 11, or x is equal to what? Take the negative 11 over, it becomes what? X is equal to positive 11. These guys are what we call the roots of the equation, the solutions of the equation, the critical values of the equation, the x-intercepts of a quadratic function. These are things you will learn next year, grade 9, quadratic functions and x-intercepts of the quadratic function specifically. So I hope that's clear. For those that decide to use this method, because you see, you can do this. Take negative 121 to the other side, right? I don't particularly like this method because learners forget to do this particular thing. Then you take the square root on both sides. When you do so, must make sure you write plus and minus. And this is what the learners usually forget. They forget to put plus, minus. So x is equal to plus 11 or x is equal to negative 11. Those are your two answers. That's also a method that you could use that is different from this one. Okay? Moving right along. We are here now. X into x minus 7 plus 5 into x minus 7 is equal to 0. Look at this. If you look at the expression, what type of expression do we have here? We have an expression whereby the type of factorization we can apply is what? We can apply what? Common bracket. We always ask ourselves, is there a highest common factor? And here we can see, guys, there's a common bracket x minus 7. So we are going to take out x minus 7 as a common bracket. What are we left with on the right? When we hide x minus 7 this side, what do we have? We have x. Then when we hide x minus 7 on the right, what do we have? Plus 5, which is equal to what? 0. So where are we now? We are in the factor stage. 0 product of factors. So if we have 0 and a product of factors, now we can apply what law? The 0 factor law. So we're going to say x minus 7 is equal to 0, or x plus 5 is equal to 0. Then from there, what do? We solve very easily and very nicely. So here we had a highest factor common bracket. We saw that because when we did factorization, we did the type of factorization where you have to take out a common bracket. How many terms do we have in the expression here? We have 1, plus sign separates 2. So in these two terms, what is the highest common factor? The common bracket, we can see that is the highest common factor is x minus 7. We took it out. What is left on the left when we take out x minus 7? We have this x that is left there. What is left on the right hand side when we take out this x minus 7? We have 5 there. There it is. Then from there, we apply the 0 factor law. The 0 factor law applied, we have x is equal to 7 or x is equal to negative 5. It is as nice and straightforward as you see it being there. All right. Another beautiful question. Okay. Right. Another very beautiful question. Okay. I will call you later. Thank you. Officer Ibu. What in the world? Who is that? Officer Ibu. Okay. Okay, let's look at the next question there. 3 to the power n plus 2 is equal to 27. Okay, so here we are supposed to do what? We are supposed to solve for what? For n, not x, but for n. 3 to the power n plus 27. Plus 2 is equal to 27. So this is an exponential equation. We want to solve for n. For exponents, guys, there's that law that says if a to the power x is equal to a to the power y, then what do we know? X is equal to y. So in essence, what are they saying? When you have the same base on either side of the equal sign, same base, look at it's a and a, then what do? We drop the base and we then equate the exponents. I think some people are having a firecracker craze. Oh, I wrote 72 instead of 27. My bad. Thank you so much. Okay, so if a to the power x is equal to a to the power y, then x is equal to y. As long as the bases are the same, we can drop the bases and equate the exponents. 27. Okay, if we don't know, we can say 27 is equal to shift fact. Take your calculator. If you want to change a composite number to a prime base, then you write, press in your calculator, 27 is equal to shift, then fact. Yes, Karabo, it will give you 3 to the power 3. Okay, very good. Okay, then you can see the bases are the same. So what do we do now? We drop the bases, we equate the exponents, because this place of bases being the same on either side we have reached. We can say n plus 2 is equal to 3. So n is equal to 3 minus 2. That means n is equal to what? To 1. Okay, as slick and as sweet as it can get. Okay, right, so these are other questions that you guys can actually take note of. Okay, this is a different question paper. I just thought let me put this out here as well, because I think obviously having not covered certain aspects because of the question paper that we have, good practice paper, this one. Look at the bottom there. Hey, these boys with their crackers, it's crazy. Okay, so study the expression. What I'll do is I'll upload these so that you guys can have them. I'll upload them just now onto the YouTube channel, not on the YouTube channel, sorry, but I'll post that here on the on the TikTok page. Okay, so that you guys can have some practice questions to do, right? And then maybe what I'll do is I'll come back and do this one, because guys, I'm kind of out of time. Okay, I'm out of time. Me has to do other things. Okay, other things that are pressing on my time, and yeah. But here it is. You can see these are other questions that you could have possibly had. Okay, look at that 5.2.2. The misconception of most learners there, 5.2.2. Look at that, simplifying. Learners, they don't apply BODMAS, right? 5.2.2. They take the 2x and they subtract. No, you can't. You can't take that 2x and subtract x. You have to first take the negative x and distribute it inside the bracket. Then you add and subtract like terms. Okay, these are things that we need to make sure that we don't, mess up or butcher. Right, so I'll put this mock exam so that you guys can have and do. Look at, for instance, 5.1.1. What is the value of the constant term? All right. At first glance, you look at that thing, you're like, I was saying there's no constant term. You think so, right? But I'm sure you can see that first, second, third. Look at the fourth term. The fourth term is a constant term. It's just that it's hidden. So the plus 4x to the power 0. X to the power 0 is actually equal to what? To 1. So we have 4 times 1. So the constant is 4. Do you see that, William? Yeah, I can see you see that. Yeah, but the thing is, Elena or someone else will look at that and be like, I don't see a constant. Remember, a constant term is a term that has no variable. So x to the power 0 is actually 1, and 4 times 1 is 4. So there is a constant. It's plus 4x to the power 0. 5.1.2, what is the coefficient of x to the power 5? Another misconception that learners can fall into there is thinking that it's only negative square root 4. But guys, it's actually negative square root 4 over 3. That is the coefficient. You write the entire fraction with the sign. You write the entire thing. Obviously, you don't write the x to the power 5. The coefficient is the number that stands next to that variable that they are talking about. In fact, everything that stands next to that particular variable with its exponent that they have identified. So it would be negative square root of 4 over 3. That would be the coefficient of x to the power 5. And then they write the expression in descending exponents of x. Guys, obviously, you are going to start with the x to the power 5 term. First, write that negative square root of 4 over 3x to the power 5. You write it like that. Then you follow it with what? The plus 6x to the power 4. That's the next term descending. Then you follow it with negative x to the power 3. Then you follow it with 2 plus 2 over 3x to the power 2. Then you follow it with what? Plus 4x to the power 0. That's how you write things in descending powers of x. Okay, yeah, and then many others that are here, which I will post for you guys to see and watch. Grade 9s, thank you so much. It was good. I actually have to leave now. Okay, yeah, I have to leave, unfortunately. So I see you guys see that there is value in joining my live sessions, and as I said to you earlier on, to those who are here, maybe you are here for the first time as a grade 9 learner. Maybe you are here for the first time and you're like, wow, guys, those who are planning to do the grade 10 maths next year, please, guys, you need to go and speak to your parent. That's what you need to do for me. And tell them that you do want to do pure maths next year and you have the potential. Hopefully you have the potential for doing pure maths next year. And if you do, and you really seriously want to do pure maths, and you want someone to help you along the way for grade 10 next year, then guys, you need to let me know, inbox me, but you need to inbox me after speaking to your parent. I do want to have a group of learners that are from grade 9 that usually join my live sessions. I want to actually get some of you to be part of my new group that I'll be starting with in December already via TikTok. We will start the syllabus for grade 10 towards the end of the year. There's a small price that I basically will be attaching to that. And guys, it will not be too much. It will be very much accessible and you will see it. But you need to first speak to your parent. Don't send me a message and be like, I'm interested. No. Speak to your parent first and say, you joined my live. You loved what you heard. That's if both of you genuinely did. Don't go and lie to your parent. Some of you, I know you are lost. The more I explained, the more you were lost. The more I did something, you were lost even more. The more I spoke, you were like, this guy is losing me completely. Please don't send me a message if you are like that, because the thing is, I'm just going to lose you more and more. You need someone else, not me. You don't need me. You need someone else. But those that know in their hearts they need me, you need me for this year and next year, then please talk to your parent first. Go tell your parent you joined my live. You liked what you heard. All right. I already have a certain group of learners that I started with the previous year. And some of those learners, I've posted some of their testimonies. Some of them have moved from very low percentages that they used to get and getting very high percentages, some in grade 9, some in grade 10, some in grade 11. So please, guys, make it a point to speak to your parent. Let them know that, hey, mama, dada, daddy, papa, ndate, father, I am interested in that thing this guy is going to do, and it seems like he has something lined up for the holiday and also for the rest of the year next year to support me in my mathematics journey, so that I can start realizing that 85% in mathematics pure is something that is feasible and possible. 85% and above. 100 is so possible, it's not even fun. But you need to be someone who, 1, is willing to work, 2, who is willing to put in the time, and 3, who's willing to actually make sure that you join my live sessions and so forth, with obviously as a fee of some sort that is attached to that, which I said is very going to be very accessible, very accessible. That fee is not going to be like ridiculous. It's not ridiculous in actual fact. So please, if you are like that and you do want to be supported in your math journey from term 1 up until term 4, even towards the end of this year, to start off the year on a high note with a bang, that so much that you won't even need your teacher that much, at school. Even if your teacher is not teaching, or if your teacher is absent, if your teacher is focusing on grade 12, as some of you tend to say, my teacher is focusing on grade 12, he's not really teaching us. Guys, if you want to be someone that will be a resource for help even in your school, when the teacher is not there, you can stand in front of the class and be like, guys, instead of sitting here chit-chatting and having aimless conversations, let me teach you this, or let me explain this. If you want to become that kind of student, as some of my students are that are in respective schools that I've worked with, then please, guys, talk to your parent first. Let them know you are interested in this particular thing. And then, as I said, those particular learners, as they indicate that their parents have approved and are willing to maybe pay that little fee, as I said, will be there. Those learners, I will absorb them. I'll have a WhatsApp group for those learners. And then those learners will begin to basically be on that journey with me. Okay, so that's all I had to say. Please, guys, first talk to your parents so that they can give the approval, and then we can take it from there, because it is your parents basically that will basically at the end of the day also support you when I am not there at home and so forth. So thank you so much, guys. It was really good. I will post it now. William, just chill. When I end the live, I will post these papers so that you guys can have a field time having a practice, and then in my YouTube channel I'll post this live session that I did. It will take some time, but I'll eventually post it. It will be there. Thank you so much. It was really good. And I can only do paper 1 for now. I'll probably do, if it's possible, I'll do paper 2 for grade 9 in the evening. But I can't, unfortunately, because I have other commitments. Thank you.